Okay, so question 1 says 1.1. The owner of a small company wishes to establish whether advertising in a regional newspaper is effective. The table below shows the amount spent on advertising and the corresponding sales figures for the last 9 years. Okay, so there's some small company person keeps advertising on a newspaper, and this is the amount they keep spending throughout all the years. So this is the first year, second, all the way to 9 years. And then this is the sales that they are making. So they basically just want to see, is the money that they're spending on the advertising, does advertising affect the sales? Okay, so the first question we have is determine the equation of the least square regression line of the data. Okay, so this is just steps that you're going to have to take. Remember, the equation of the least square regression line is y is equal to a plus bx. Okay, so we're going to have to find the value of this a and the b, and then our equation will be complete. So let's go ahead and find a and b. So we're going to put in this information. Now, the nice thing is that they're already telling you that these are the x values and this is the y value. The reason I'm saying that is because they don't necessarily have to actually tell you that. They can actually just say the information, and then you're going to have to think about which one would be your independent or your dependent variables. Okay, but in this case, they already gave you that. So with this part, just be very careful as you're putting in the information. So as we're going to put this in, this is what we're going to have first. You're going to, first of all, on your calculator, so on your own physical calculator, you're going to first press mode. And then when you press mode, you're going to see 3 options, I think, pop up. So I'm not really using a Casio calculator, but it is a scientific calculator. Then you're going to go ahead and press. Okay, so never mind. I found the Casio calculator, so I'm going to be using that. Okay, so I am using the old one. I do think the way it works is still exactly the same. I think they just changed the way it looks. So first of all, we press mode, and then you're going to see 3 options pop up. One is going to be comp, then stat, and then 3 for table. So since this is information that we need to put in, it's not functions. We're going to go to stat, so statistics, so 2. And then you're going to have a whole lot of options, and you see that number 1 says variance, VAR, and then number 2 says A plus BX. So that is about regression. You're going to choose number 2. Okay, so as you can see with mine, I am still going ahead. So mode, then I choose stat, and then of course I'm going to go to this A plus BX, that, because it's the paired, the bivariate data. So yes, you're also going to have something like this. You may not have a frequency table like this side. So let's put in the x values first. So the first x value you have is this 21300. Just carefully put everything in. I'm going to put everything in now, and then just make sure that everything is in properly. Okay, so these are all the x values that I've put down. You will see that on the side on your calculator, you're going to have numbers. So just make sure that you end at 9 because they are 9 years. Okay, then move on to the y column, and we're going to put in the y values, the sales. Okay, so now that everything has been put in, the y and the x values, on your calculator, you're going to press the button AC, and then you're going to press Shift and 1. Okay. And then you'll see that you're going to have like 6 options, but you just have to go for option number 5, which says REG for regression. And then you'll see that you have 5 options, and number 1 and 2 give you the value of A and B. So let's go for number 1 first. So you're going to press 1, and let's see what that A is equal to. Okay, so my A value, I get 1730 points, and then rounding off to 2 decimals because this is money that we're talking about, so that will be 22. Okay, so that's the value of A. Now in order to find B, you can just press AC Shift 1. Even if you just press Shift 1, it will work, but I just like to press AC. So AC Shift 1, and then again you're going to go back to that whole thing with the 6 options. Then you just have to choose option 5 for regression, and then after choosing option 5, you're going to go for number 2 this time because we want to find out what B is. So if you go for number 2, you see that B is actually just equal to, and we get 13.96. Okay, so now as an equation, this is just y is equal to the A value, which is 1730.96, 13.22, and then plus, this is positive, so we can say plus 13.96 and x. And there we go. So that's the equation of our least squares regression line. Okay, so moving on to the next question. The next question says, predict the sales for a year in which the company will spend 28,500 Rand on advertising. Okay, so look for what they are asking you for. They want you to predict the sales. Okay, so let's see. What does the sales refer to, X or Y values? The sales refers to Y values. So they want you to find the Y value, okay, for which the company will spend this amount on advertising. Okay, so they're spending this on advertising, and advertising is referring to the X values, the amount spent on advertising. So that is X. So they're giving you an X value. They want you to find a Y value. To predict this, you're going to use the equation of the least square regression line, because that's all we have right now. Okay, we never drew a scatter plot or anything. So we're looking for Y. So we're saying Y is equal to, and we have 1730.22 plus 13.96. And then in place of X, we're going to put this amount. So that is the 28,500. And let's go ahead and see what we get. Okay, so the nice thing about these calculations is on your calculator, even if you press AC, it's not going to remove the information. It's still recorded, and you can still do normal calculations here. So I'm going to do that calculation. 17,030.22 and then plus 13.96. Open bracket, and we're saying 28,500, and we're going to get an amount. So let's take that. So that is our answer there. So the amount, or the predicted sales, is going to be 399,590.22 cents. Okay, so that is 1.1.2 done. Moving on to the next question. They want us to write down the correlation coefficient of the data. So the correlation coefficient is going to be found in the recorded data that you have. On your calculator, just press AC, then shift, and then 1. And then when you press that on your calculator, mine is a bit different, you're going to get those 6 options again. Go for option 5 for regression. And then again, you're going to get the 5 options. And this time you're going to choose option 3, which is R. Okay, so that's your correlation coefficient. So let's see what that is. So as we can see, R is equal to, if we round off to 2 decimals like we're supposed to, it is 0.98. Okay, so sorry, I put it in the wrong place. 0.98. Okay, and then moving on to 1.1.4, which is the last question regarding this bivariate data. So we have described the association between the amount spent on advertising in the regional newspaper and sales of the company. So they want us to describe the association. When we speak about that, this is what you're going to have to remember. You're going to have to remember how the correlation coefficient works and the association that is attached to it. Okay, so let me just run through the correlation coefficients and what they mean. I'm not going to go too deep into it. So looking at these numbers, they just represent different correlation coefficients. If your correlation coefficient is 0, there is absolutely no correlation or association, meaning that your data has nothing to do with each other. The X values are not affecting the Y values. In other words, the amounts that they keep spending on advertising is not affecting the sales. That's what a correlation coefficient of 0 would mean. This one would be weak. Okay. 0.5 is exactly halfway. So this would be moderate. Okay, so just in the middle, moderate. And then this 0.9 would be regarded as strong. And if your correlation coefficient was 1, that would be perfect. And this works the same with the negative numbers as well. Okay, so -1 will also be perfect. So when we speak about the correlation coefficient, you first really speak about their strength, and then you speak about whether it is positive or negative. And then you say it's an association. So here we have 0.98, which would fall within this. So around 0.9, that is a strong association. So this is how we're going to really just say this. It is a strong, and remember the number is not negative, it's positive. So it's a strong positive association. Even if you said strong positive relationship or strong positive correlation, it's still going to be fine because it's really just speaking about the relationship between the two values. Okay, so that is exactly the X and Y values. So it means that really in this information, the amount that they keep spending on advertising is actually affecting the sales. Okay, so you wouldn't really need to put any of this down. I just put that there just so that we can write that down. Okay, so you would just really need to say this part written in black, that's all. Okay, so that's your answer there. Then the next question, we move on to 1.2 and we have been given a new set of data. So we won't need this anymore. Okay, so 1.2 says the profit that the small company made over the same 9 years is given in the table below. So you see in the previous one, they gave you the sales, but here we're actually talking about the profits. Okay, I'm going to remove this information. We're not going to need this. Okay, so you can go back to comp. We will go to stats, but it's going to be a different way. So first of all, we've been given these 9 numbers because it's for 9 years. And they want us to calculate the mean profit made over the 9 years. Okay, so this is worth 2 marks. We can use the calculator to calculate the mean without actually adding it up together. So to find the mean, we're going to say this. On your calculator, you're going to press mode. Then again, remember we are speaking about statistics, so stat. Then this time, you're not going to choose option 2 anymore for .a plus bx because we're not using bivariate. This is one set of data. So we're only using one value. It's not bivariate. It doesn't have 2 sets of data. So we're going to go for option 1 for variance. So you're going to see you're being given a column with numbers like 1, 2, 3 going down, and then it's written X on top. So we're going to put in these values in here. Nicely put them in. Try to make sure you don't make mistakes with it. And then let's see what we have. Okay, then after you've put all the information in, you're going to press AC, Shift, and then 1. Then on your calculator, you're going to have 5 options: type, data, sum, variance, min, max. Okay, so you're going to go for variance, number 4. Okay, I apologize. I keep using the word variance. It's not variance, it's variable. So it's speaking about the amount of variables. So it says 1 variable. So the ones with just a single variable, not like the one we did here with 2 variables. Okay, so once you press that, you're going to see that you have 4 options. Number 1 says N, which is really just the frequency. Number 2 has this symbol, which is for mean. Okay, so just press option 2 is equal to, and let's see what we get. Okay, so the mean, we get 172,466.11 cents, and this is money. So this is the mean, or basically the average of the profits that they have made in the 9 years. Okay, then the next question after the mean, we have to write down the standard deviation of the data. Okay, so to find the standard deviation, you can go ahead and press AC, Shift 1 again. Then again, you're going to see your 5 options. You're going to go for option 4, which says variable, so option 4. And then we want the standard deviation. So the standard deviation, the symbol of it looks like this. So yours may say this and X, but even if it's just that, it is still the standard deviation. So the standard deviation, that's option 3. And you can go ahead and say is equal to, and let's see what we get. So the standard deviation is 56,950 point, round off to 2 decimal places, 09 cents. Okay, so that's our standard deviation. And remember, the standard deviation really just measures, it is a measure of how spread out your data is. So the mean would really just measure the average. Like if you took a class test, they can test the average of the marks that you guys received. Then the standard deviation will tell you more about how spread out the data is, meaning how close it is to the mean. Okay, so that is 1.1.2, and then moving on to 1.2.2. Then moving on to 1.2.3, we have determined the number of years in which the company made a profit that was greater than 1 standard deviation above the mean. Okay, so we have to find out the amount of years where the company made a profit that was greater than 1 standard deviation above the mean. A way that you can look at this to understand this is we're looking at the mean, right? And we need to move one standard deviation above the mean. So if we're moving above the mean, we're going to add. It's kind of like we're moving to the right. And we're going to add by one standard deviation so that we can be one standard deviation above the mean. So if they said 2 standard deviations above the mean, it's like looking at, you have the mean here and you're going to move 2 standard deviations. Okay, so like 2 times the standard deviation. If it was below the mean, if they said 1 standard deviation below the mean, you'll be looking at the mean and you'll be moving this way instead to the left, meaning you'll be subtracting and you need to just go 1 standard deviation below the mean. So it'll be the mean minus the standard deviation. Okay, so that's really how to work out these ones. So first of all, we need to find out what that mean plus the standard deviation is, because this will be 1 standard deviation above the mean. Okay, so let's find out what mean plus the standard deviation is. So the mean was this number, which I'm just going to put down. And then we have to say plus the standard deviation, which is this amount of 56,950.09. Okay, add this on your calculator and let's see what we get. You don't have to worry about the data. We don't need it anymore. As you can see, this is the last question in statistics here. So I'm going to just put the calculator back on the normal setting. You just press mode and number 1 for comp. And we get 229,416.20. That's how much we get. Okay, so that solves that mean 1 standard deviation above the mean part. But now if we look closely to what they're actually saying, they're saying we need to determine the number of years in which the company made a profit that was greater, okay, than 1 standard deviation above the mean. So if this is 1 standard deviation above the mean, we need to look for how many years did they have a profit that was greater than this amount. Okay, so we're going to look in the information. What was greater than this amount? Okay, so let's see how much numbers here is actually going to be greater than this number. Okay, so greater than that. You see, this one is not greater than it. This one, it's in the 100,000s, not greater, not greater. Okay, let's compare this one. As you can see, this is greater than that. So that we're going to take 1. This one is less than that. This one is definitely greater as well. This one less than. This one, it's less than. So we cannot take that, and that's less than. So as you can see, we only have 2 profits that are literally greater than 1 standard deviation above the mean. So you need to remember how to answer this. The question is determine the number of years. Okay, so how many years did they have a profit greater than 1 standard deviation above the mean? That is 2 years, because 2 profits were greater than a standard deviation above the mean. So you need to just conclude 2 years. Okay, that would be the answer. Okay, so that is it for statistics. Well, no, just this part. Yeah, we still have this. Okay, so that is it for 1.2.3. And then we move on to question 2 with group data. So now we're on question 2, and question 2 says the ages of people who attended a music concert were summarized in the table below. So here's this table, and the first question is to write down the modal class of the data. So the modal class really refers to the mode, but in this case, this data is in classes. So the mode would be the number with the highest frequency. Because remember, the number of people, okay, the frequency, that's just really how many times this information would occur. Okay, but these people are being grouped in classes, because they're not really going to now represent all the ages of each people. These people are too much, so it's in a group. So we're just going to take the thing with the highest frequency. So here, that frequency is 90. That's the highest. So the class for the highest frequency would be this. And so we're going to take that. That is where X is greater than 35, but less than or equal to 45. So people who attended this concert the most would be within this age range. Okay, the next question. How many people attended the concert? So remember how all of this is speaking about the number of people. So to find out the amount of people that they are, you would just have to add all of these numbers up and we will get that. Okay, so I'm going to add everything up and let's see what we get. Okay, so when I add all the number of people up together, we get 320. So it means that there were 320 people, okay, that attended the concert. Moving on to the next question. 2.3, they say, on the grid provided in the answer book, we need to draw a cumulative frequency graph, an ogive, to represent the above data. Okay, so I just pasted the ogive that they gave. Nicely, they've already told you that they're already doing this for you, and that's really nice. So you just really have to plot down the information. Okay, in order to plot down an ogive or cumulative frequency graph, we need a cumulative frequency column. And this is how we can create that. So that, I'm going to put cumulative frequency here. And this is how we calculate this. So very easy. We're going to take 20 first and drag it to the side. So we have 20. And then we're going to say 20 plus 25, and that gives us 45. Then 45 plus 60, and that will give us 105. And then 105 plus 90, and that'll give you 195. Then 195 plus 55, that's 250. And then 250 plus 40, 290. And then 290 plus 30, which is 320. So you see we ended off at 320, so we know it is correct. Okay, so that would be your cumulative frequency. Okay, and this is how we're going to now plot this information down. So remember, you have an x-axis and a y-axis. How we're going to put the information down? On the x-axis, okay, this is the age of people. As you can see in the data, this is the age of people. And then this will be our cumulative frequency. Don't use the frequency, use the cumulative frequency. That will be on the y-axis. So this is how we're going to put it down. The first one you're going to put down is going to be 5, whatever number starts here, okay? It's 5 in this case. The x value will be 5, and the y value will always be 0. That's where you start. So your x value is 5, your y value is 0. So as you can see, this is from 0 to 10. So we need to go halfway in between. We need to say 5 and 0. Okay, so looking at the way this thing is counting, it's counting in intervals of 5. So it's like 0, 2, 4, 6, 8, 10. Okay, so since it's 2, 4, this is 4. And then 5 will be in between that. So I'm saying 0 and 5. And I'm putting that dot on the x-axis itself. Okay, so I'm putting this dot here, and then I'm going to put 5. Okay, this is the 5, and of course the y value is 0. That's where it must always start. Okay, so that's the first one. Always remember that one always goes with 0 as the y. Then here, the next x value we're going to have is going to be the 15 and the 20. Okay, those go together like that. So 15 and 20. 15 would be in between this. So I'm going to go 12, 14, in between would be 15, and then 20. I don't actually have to write these numbers. They can't see. Okay, so 15 and 20. This is counting in tens probably. So 10, 20. Okay, so we're in between here for 15, and then 20 is just going to be 2 up. So that's where that dot is going to be. I'm not going to put these numbers. It's not really necessary. Okay, next one is we have the 25, and we're going to take 45. Okay, so 25 and 45. Okay, 25 is just in between here. So 1, 2, and in between there is your 25. Then we're looking for 45. Since this is 50, it's just going to be halfway. So halfway, this is 50 here. Halfway in between here, kind of there in the middle. And then we have the 35, and we're taking that with 105. So 35 and 105. 35 is in between here. 105 is going to be, so here's 100. So halfway, just a little bit higher. Since this is the 100 mark, we're going to say just a bit higher than that. So just maybe here. Okay, so halfway in between. Okay, that is the next one that we have. And then we have 45 and 195. 45 and 195. That will be here. 45 is in between here. Then 195. That's going to just be we have 150, then 190 is going to be just below the 200, okay, because that is counting in tens. So here we just go move up and reach the 200 mark and just go a little bit below it and just mark that in between. Okay, so there. Then we go for 55 and 250. So you get how it's working now. 55, 250, 55 is in between. 250 is already here. So we're just taking the in between of that. So here, 55 and 250. Okay, and then we're going to have 65 to 90. Okay, 290 is a easy number to get. So here's 300, 290 is just one below it. So 65 would be in between and 290. So we have 290 just here on that line. And then the last one, which of course is 75 and 320. So 75 and 320. 75 in between 320 would be just 1020. So 2 lines up here and in between these two. So somewhere here on that dot on this line. Okay, so there is our ogive. And now you just have to join it. Okay, so it doesn't have to be perfect. It's going to kind of look like a little bit of a curve, like an S. So we're going to join it. It is just from here. We just join all of these points, move down. Okay, and there. Okay, so that's the ogive that we have, and it is drawn. That is for 4 marks. Okay, moving on to the next question. They say, use the cumulative frequency graph to determine the median age of the people who attended the music concert. So we're going to use that graph that we just drew to determine the median age. So to find the median, very simple. All you're going to do is, because the median is speaking about halfway of the data, we're going to say, to find the median, first of all, of course, the position of the median, we'll say a half multiplied by the total number of people. Okay, so that would be n, the frequency, the total frequency. Now, the total frequency or the total number of people in this data is 320. We already know that from here. There's a total of 320 people. So you will notice it's always going to be the total that you found in the cumulative frequency. So that is 320, and let's see what that gives us. Okay, half of 300 is 150, half of 20 is 10, so that's 160. Okay, so that is the position. That's where the person is. Now we actually have to find them. Remember, I only took the number half and I multiplied it by 320, which is speaking about the number of people. Okay, so this right now, you will go to the frequency, the cumulative frequency, and we're going to look for 160 there. So on your graph, we're going to the cumulative frequency part, and we're going to look for 160 here. So 160 here, here's 150, here's 160. So I think on this it'll be easier because just in your exam, make sure you use a ruler. So here, I'm just going 160, and I'm going to draw a line until I touch the curve. So I touch the curve over here. The minute you touch the curve, you start moving down. So if you move down, you see that this is where we land. So it's just past 40. Let me estimate round about where this is going to be. So if this is, okay, so looking at this, it's around about 41, 42. It could also be my fault because of the way I drew the curve. Maybe I didn't really curve it well enough, because I can even see a little bit of a hunch here. It should have at least go like that. But anyways, okay, so what we get for 160, if you say that the median, okay, the median age, so the median age, as we can see, we got around about 41 or 42. I'm just going to say approximately is approximately 41 years. Okay, because this is age. So this would be the median. So this is the median age that we have. We have people that are 41 years old. So we are on question 1, and question 1 says, a survey was conducted among a group of learners to compare the time spent on Instagram to the time spent on TikTok. So the results are shown in the table below. So this is the time spent on Instagram in minutes and the time spent on TikTok. And they're already represented in a scatter plot. As you can see, the time spent on Instagram is what is on the x-axis, and then that's on the y-axis. So the first question, 1.1, says, calculate the correlation coefficient of the data. So remember, to do this, you need your bivariate data. Now, it's bivariate data because we have two variables in this data. We don't just have one set of data. So you're going to go on your calculator. I'm going to be using my calculator this time. I know that in the past, I have tried to use a Casio calculator, but I'm just going to stick to this. And because I have a Casio calculator out here, I'll also just make sure to check the steps on that calculator as well so that you can follow along. Okay, so to record this data, let me actually just move this here. You're going to go ahead and press mode on your calculator, and then you're going to see various options. It won't look like mine, but you'll have some options. And I want you to go ahead and pick option 2 for stat. So you're going to take stat, whatever that is on your calculator. And you're going to see other options as well. Now, the type of data we are working with is bivariate data. So these are data that have two variables, okay? So we have X and Y. So what we're going to do is we need to take the one that says number 2a plus bx. So make sure you go for that option. So on my calculator, I'm just going to go ahead and move around like to actually find that. So I'll go to my data, and then I'm going to go to where my bivariate data is. Okay, so seems like I already had something recorded there, probably from another exam. But we're going to go ahead and put this in. Remember, this is the values on your x-axis, and that's the one on your y-axis. Okay, so when you click that, you're going to see an x and a y column, and you need to fill them in. So once you have put in your x values, you'll notice that on your side, you're going to have numbers. Make sure that you end at number 6, so that you know there are actually 6 values in the x-axis. So now on the y, okay, the y values, we're going to go ahead and put down those y values into our calculator. And once you have put down these values, you can go ahead and press AC, Shift, and 1. Okay. So on your calculator, you'll see that you have 6 options. And I want you to go ahead and pick the option that says number 5, REG, for regression. So when you go for that option, mine, again, it is a little different. So I have to go to regression over there. I want you to go ahead and pick the option that has an R, because that would be your correlation coefficient. So on your calculator, it will probably be number 3R, like that. So I'm going to go ahead and say, what is that? And then press equal to on your calculator. And that is our correlation coefficient. So the correlation coefficient of this data is this number we see here. You can round off to 2 decimals. So that is 0.96. So R equals 0.96. And that is for 1 mark. And we move on to the next question. So the next question, 1.2, says, comment on the strength of the correlation between the time spent on Instagram and the time spent on TikTok. So they're really just asking you for the strength. You don't really have to start giving explanations. However, what they're really just referring to here is when you're looking at the data, right? The data is actually trying to, the data assumes a specific thing. In this case, we have the time that people spend on Instagram. And as you can see, it starts to increase. So for example, over here, we have somebody who spent 30 minutes on Instagram, and then they spend 40 minutes on TikTok. And then if somebody spends 45 minutes on Instagram, which is an even higher time, do you see that they start to even spend a lot of time as well on TikTok? Okay, so that is the thing here. We're seeing a trend going on. When someone spends a lot of time on Instagram, they also spend a lot of time on TikTok. Okay, but we have to actually just be simple with this answer. We don't have to overthink it, because they just want you to comment on the strength of the correlation. How you comment on the strength of the correlation is like this. So the strength of this correlation, because it's 0.96, okay, 0 would be absolutely no correlation. If you have a correlation of 1, that is a perfect correlation. So 0.96 is within here. As you can see, it's moving more to the right. So these are where you get strong correlations. Okay, so I'll just be specific here. I'll just say there is a strong positive, okay, because that correlation is positive. So it just means that the trend is generally increasing, okay? It's not like a decreasing function, it's an increasing function. So there is a strong positive correlation. And that is enough, really. Okay, moving on to the next question. Then 1.3 says, determine the equation of the least squares regression line for the data. So remember that the regression line's equation is y equals a plus bx. And you would have seen that when you were working on your calculator, okay, to put in your bivariate data. So we just need the value of a and the value of b. And we can use our calculator to find that. So on your calculator, you can just press shift and 1, okay, to bring back your data so that you can look at it. And you're going to, on your calculator, choose option 5 for regression so that you can get that information. And when you choose that, you're going to see your options for A, B, and R and that, okay? So let's go ahead and pick number 1 for A and say equal to. So if I pick A, what I get here, oh, that's odd A, so it's going to multiply. I need A, which is 8.12, okay, rounded off to 2 decimal places. You can go ahead and also check that. And then B. So again, what I'll just do is erase this. You don't have to do that, but you can just press shift and 1 on your calculator. And then again, choose number 5 for regression. Then you're going to go for number 2 for B to find that B value. So B is equal to 1.01 rounded off to 2 decimal places. And then we can go ahead and substitute. So this means that the equation of the least squares regression line is y equals 8.12 plus 1.01x. And that is our answer. Okay, now moving on to the next question. Okay, the next question says, predict the time that will be spent on TikTok if a learner spent 115 minutes on Instagram. So we already have the equation of the least squares regression line, and we can use that to make predictions. All you have to do here is see which values exactly do these belong to. So the TikTok, right? Were these the X or the Y value so that we know what we're looking for? Remember that TikTok was on the y-axis, okay? So those are the y values. So they're really asking you to find the y value if your x value, which is Instagram, because Instagram was on the x-axis. So if your x value is equal to 115, and we can use the equation to do that. So y equals 8.12 plus 1.01. And in place of x, we're going to go ahead and substitute our 115 minutes. And you can calculate this on your calculator. So you don't have to worry about the fact that the data is here. It can actually still do calculations normally. So we can go ahead and punch that into the calculator and see exactly what we get when we do that. So 115. And you see our answer. So y is equal to 124.27. So remember that this is in minutes, okay? So you can, of course, tell them minutes. And it's fine if you don't round off in this case, because it is minutes. They can convert that to seconds, but it's fine. It's still in minutes. Okay, so that is our answer over there. And then we move on to the next question. Then question 1.5 says, it was noticed that 4 learners' data was not recorded. Okay, this is very important. 4 learners' data was not recorded. And now they say the mean time of the TikTok users and Instagram users was this. Okay, was 73.4 minutes each. Now, I wonder, do they mean the new time, right? The new mean, because these 4 learners were not recorded, or are they speaking about, it's probably the new mean. However, we can actually find out this easily. So because they say that it is 73.4 minutes each, right? If you wanted to find the old mean, just to ensure that, yes, this is a new mean, we can actually find that out on our calculator. So you can just press shift 1. And then when you do that, instead of going to regression, we want to find out more about those variables that we have. So you're going to pick number 4, okay, VAR, You go to that, and then you can actually check the mean of the X values. So if it's not this, then you know that this is a new mean that they're actually giving you here. So let's go ahead and check the mean. So you would take option 2 for mean. And yeah, my calculator always does this. So I kind of have to delete everything there first before I can actually get that. So our mean here, shift 1, and I need to go to that, is this. Okay, 60 point. So yeah, definitely this is a new mean. I was just trying to make sure. So this mean, right, is the new mean they found after they recorded the 4 learners that they forgot to include. Okay, and what they tell us is that the mean time for TikTok and Instagram users was this each. Okay, so we have to keep that in mind. For TikTok, the mean was 73.4, right, minutes. But for Instagram as well, it was also 73.4 minutes as well. So that's what we have. This is when the 4 learners have been included as well. Then they tell us that the researcher commented that the total number of time spent on the 2 social media platforms. So the total number of time spent on these 2 social media platforms combined, right? The 2 of it combined was more than a full day. And the question is, do you agree with the researcher? Motivate your answer by using necessary calculations. So for the time that they spent in total to be more than a full day, we need to actually see the total time spent. I want you to notice that this is the mean, okay? It's not the total time that was spent by all the learners. What this is on average the time that was spent by each learner, okay? So that's the mean, the average really. So on average, we can say each learner spent about 73.4 minutes on each social media site. So now we actually have to find the total amount of time spent on the social media platforms combined, of course. So first of all, let's find that total of TikTok. If we know that the mean is now that, right? Is now this number. Well, how do we calculate the mean? Well, calculate the mean by finding the sum. Okay, or we can use sigma because that is for sum. So we find the sum of all the X values, okay, and I'm going to say, let's start with TikTok, over the total number of learners, okay, because we want to actually just get the total number of time spent by each learner combined. Now, how many learners are there? Remember that in our data, right, when we looked at this, these are the learners that we have. So they're the same learners in each line. So this is one learner, right? This learner spent 30 minutes on Instagram and 40 minutes on TikTok. So it means that here there was 1, 2, 3, 4, 5, 6 learners before. But they told us that they left 4 out. So now it means there's actually a total of 10 learners. Okay, so that's what we're going to have to do. So we can go ahead and find the sum of the total amount of learners. So the mean time, that was 73.4. And that is equal to, we don't know this yet, we're just trying to find that, over 10. So you see now to find the total sum of all those learners, right, the time that they spent on one platform, Instagram, you're going to have to get rid of the 10. You can decide to cross multiply or just multiply both sides by 10 to get rid of that 10. So it would mean that the sum of times that they spent on Instagram would be times 10, which just means that the decimal just moves one place. You can also use a calculator. If you calculate on your calculator, it's not going to erase your data. And so that is 734 minutes in total. And this is for Instagram. But you see that the mean time is exactly the same and there's the same amount of learners. So this is for each platform, okay, for Instagram and TikTok. So now that we have that, the researcher commented that the total number of time spent on the 2 social medias combined, okay, this is just the total number of time spent on, let's say, Instagram or TikTok. The total number of time for both of it combined would be, you would have to add them together, because this means that they spent 734 minutes on Instagram and 734 minutes on TikTok. So if you add those together, we're going to have to go ahead and work with that. So 7 plus 7 is 14, and then 34 plus 34 is 68. So that's the total amount of time in minutes that they spent combined, okay? And what we have to find out is if the time that they spent was more than a full day. A full day is how many hours? Is 24 hours. So we need to find out if this number is actually greater, if this time is greater than 24 hours. Well, this is in minutes right now. It needs to be in hours to be compared to 24 hours, right? So we can convert that into hours by dividing this by 60. Okay, so if we take that and we divide it by 60, let's see what we get. So we're going to go ahead and say 1468 divided by 60. So we get 24.46 recurring, but you can just round off to that, right? And as you can see, this is in hours, and this is actually bigger than that. So because 24.47 hours is greater than 24 hours, then the time that they spent combined is actually greater than a day, and it means that the researchers were actually correct. So if you look at all the time that the total learners spent on Instagram and TikTok combined, it's actually more than a day, an entire day. Okay, so that is that question, and that was the last question for question 1, and then we move on to question 2. We are on question 2, and question 2 says, the amount of money in rands that a group of learners spent at a theme park on a specific day was recorded. The data is represented in the cumulative frequency graph, an ogive, below. Okay, so there is our ogive, and it's already completed, so you don't have to draw it in this case. So as you can see on the x-axis, we have the money that was spent, and then we have the cumulative frequency. So that has to do with the learners, okay, that spent the money. So we're just recording the amount of money that groups of learners really spent at a theme park, okay. So here is our data. As you can see, we have missing values. And what they tell us is that the data from the cumulative frequency, the ogive, is represented in the incomplete frequency table below. And the first question is, how many learners visited the theme park on that specific day? So they actually want to know the total number of learners. And when we look at this, it's like, how can we actually find the total number if we can clearly see that A and B are missing? Well, they gave us the ogive, and that's the thing about it. You see the ogive, you just have to go to the last point that you had. Okay, it's a cumulative frequency, so the frequency is accumulating. So the highest frequency that you have there, okay, since this is the learners that we have, would be this number over here. That will be the total number of learners that you're finally going to have in total, since we keep adding the learners as we go to the next point. So that's, okay, the number that you have there, not just the number here, specifically that point, the Y value is 25. Okay, and that's how we would know that in total, there are actually 25 learners that visited that theme park on that specific day. Okay, so there we go. That is question 1. And then 2.1.2 says, determine the values of A and B in the frequency table. Okay, so we can actually find these values, and how we can find them is by looking at the, well, not really the cumulative frequency. You don't really need that. You can use it. It would be somewhat helpful. But because this is complete, we can actually use that to find this. So A is going to be super easy to find, because how the ogive goes is it starts at 0. Like I always explain there, okay? Whatever value you have here, see, 10, that one, its Y value must be 0. And then when we go to the next point, 50, okay, that's going to be the value, the Y value that you have there. So as you can see, the Y value here is 3, and that's how we know exactly what A is. Okay, A is 3. So it means there were 3 learners that spent between 10 Rand to 50 Rand, okay, at that theme park. So that is 3 over there. And then now this becomes so easy to find because only B is missing, and we know the total number of learners they are. There are a total of 25 learners. So this is our equation. We can add everything, 3, the 6, the 8, and the 2, right? And when we get that, B would just be 25 minus the addition of everything, since it's the only thing that is missing. Okay, so that's how we can actually find that there. So let's go ahead and add. If you like, you can make it an equation. So that is the 3 plus the 6, 8, and 2. Okay, so 3 plus 6 plus 8 plus 2. Then you can say plus B is equal to 25, because if you add everything up together, you should get 25. Okay, and then we can just solve for B in this equation. So we can go ahead and say that B is equal to, and we have 25. If you add all of these together, you get 19. Okay, and so you take that positive 19 over and becomes a negative 19. And then 25 minus 19 is going to give you 6. And there we go. So we know what A is. I should have put A down first. Okay, I only wrote it in the diagram. But we know what A is and we know what B is as well. So this is B and A is equal to 3. Okay, so there we go. Moving on to the next question. The next question, 2.1.3, says, use the ogive to determine the percentage of learners that spent more than 175 Rand. So we want the learners to spend more than 175, right? But remember that they want it to be written as a percentage. Determine the percentage, okay? So let's go ahead and find the total learners that spent more than 175. Then we're going to convert that into a percentage. So we can use our diagram, our ogive specifically, to do this. So we're looking for learners that spent more than 175. So where is 175? Okay, so we're just going to have to understand how these intervals work. We have 0, we have 10, 50. If 50 is here, this is the middle. Then between 10 and 50 should be 30, because you can say 10 plus 50 divided by 2, 30. And so since you can see now we're adding 20, see, okay, 10 plus 20 is 30, 30 plus 20 is 50. We should add 20 to get 70 and 20 to give you 90. Okay, so they actually structured this incorrectly. This should not be 10. So as you can see, they structured this a little weirdly. So it's really not something that maybe you should worry about. Let's just try to find 175 like this. Since they are going in this order, we'll start at 50, right? And we can actually just count from here because these ones seem more consistent. So 50 to this midpoint, we can say that that is 75. And then plus 25 is going to be 100. So we're counting in 25s. Okay, plus 25, of course, is 125. Plus 25 is 150. Okay, so to get that, plus 25 would be 175. So there's where 175 is. And then, of course, plus 25 will give you 200. Okay, so now that we know where 175 is, what we can do is to find out the amount of learners that spent 175. First of all, you're going to go ahead and line that up to the ogive. And once you touch the ogive, you go ahead and start going to the side. So I touched it here. I'm going ahead and go to the side like that and find out exactly how much that is. So let's just also see what is this counting in. So we have 15, 1, 2, 3, 4, 5. So it's in intervals of 1. Okay, so it's just 15, 16, 17, 18, 19, and then 20. So this is how we will find out now the people or the amount of learners that spend more than 175 Rand. It means that the total learners, right, that spent 175 or lower than 175 would have been 19. Remember, this is a cumulative frequency. So it's counting the accumulation of the learners, okay? So for example, if a learner spent between 10 Rand to 50 Rand, we can see that the total amount of learners there was 3 learners that spent it, okay? And then the learners who spent between 50 Rand to 100 Rand, it's not actually 9, okay? What it actually is this 9 represents the total amount of learners that spent from 100 Rand to below 100 Rand. That's what the 9 stands for. So the 9 here, right, includes this 3. So if you actually wanted to separately find out the amount of learners that spent between 50 Rand to 100 Rand, you'd have to say 9 minus 3, which is 6. And that makes perfect sense. You see, the learners who spent between 50 Rand to 100 Rand was 6 learners. Okay, that's what I mean by this is an accumulation of the learners. So if you're looking at this 175, this is the total learners that spent either 175 or anything lower than 175. That was 19. We're trying to find out the learners who spent more than 175. So to find that, we're going to look at this. Since 19 tells us only the learners who spent 175 or less, we're going to go beyond this by going here. We're trying to look for the learners who spent more than 175 Rand. The highest they could have spent is 250. So since we know that the highest amount they could have spent is 250, we can just go ahead and take this. This 25, remember, stands for the total amount of learners that you have, right? And since the 19 stands for people who spent 175 or less than 175, to find everybody who spent more than 175, you're going to take the total number of learners minus the people who spent either 175 or less than 175. And that would give you everybody here who spent more than 175. So that would be 25 minus 19. That's the calculation we must do there. So 25 minus the 19, which we've actually calculated this before, that gives us 6. So it means that 6 learners spent more than 175. Now, remember that they said that this needs to be put as a percentage. So we're going to say 6 out of how many learners are there? There are 25 learners in total. Then you have to multiply this by 100 to put it in percentage. Okay, so as a percentage. So that is 6 over 25 multiplied by 100, which is 24%. Okay, so what that means is 24% of the learners spend more than 175 Rand. Okay, so that's how to answer these questions that say more than that. You're really just looking at the people who spend more than that, since these are accumulating. Okay, so that is it for that question, and we move on to the next question. Okay, we're on 2.2, and it says, it is further given that there are 2 rides at the theme park, the Intimidator and the Terror Thrills. Now, they say that the mean amount of money spent on these rides are analyzed and is given below. Okay, so this is the mean amount on each of these rides, these 2 rides. Then they tell us that the 2 standard deviations intervals about the mean. That is a very important thing to understand. So 2 standard deviations intervals about the mean for the Intimidator was calculated as this. So that's the interval for 2 standard deviations about the mean. Now explain what that means. If the standard deviation of the Terror Thrills is double, that's another piece of information. If the standard deviation of Terror Thrills is double the standard deviation of the Intimidator, we need to calculate the interval for the 1 standard deviation about the mean of the Terror Thrill. So that's really what they want at the end of the day. Calculate the interval for 1 standard deviation about the mean. Okay, let's quickly understand what it means, what they mean by 1 standard deviation about the mean, or 2 standard deviations about the mean. Okay, what do they mean by that? Well, when you're looking at that, you're actually looking at the mean as the focused value, and you're trying to go 1 standard deviation away from the mean. But you can do this in 2 ways. You can either move 1 standard deviation away from the mean by adding by a standard deviation. You see, we're by the mean and we want to move 1 standard deviation away from the mean. Okay, so you would have to add a standard deviation, which if you do that, it's going to give you your mean plus your standard deviation, right? You can do that. And another way to move a standard deviation away from the mean, okay, so that you can be 1 standard deviation about the mean, or really a standard deviation from the mean, is also to subtract. So we could have added by a standard deviation, okay, but we could have also subtracted by a standard deviation, by 1 single standard deviation, and that would give you the mean minus the standard deviation. So the interval for 1 standard deviation, okay, about the mean, let me just call that an SD, about the mean is this. It's going to be mean minus the standard deviation and mean plus standard deviation. That is one standard deviation about the mean. So to understand the two standard deviations interval about the mean, okay, so that two standard deviations about the mean would just be to make sure that you put two standard deviations instead of one. So that would be mean minus two standard deviations and mean plus two standard deviations. So that's what they mean there. So now we can say the two standard deviations interval about the mean, okay, that for the intimidator was calculated to be this. So they already calculated that, and that is the interval that they got. They got 4.8 and 9.2. Okay, so that is that. So as you can see, if you say mean minus standard deviations, you should get 4.8. And if you say mean plus two standard deviations, you should get 9.2. That's really what they mean by that there. Of course, that is for the intimidator. Okay, so it's calculated to be that. Now the question is, if the standard deviation of the terathrills is double the standard deviation of the intimidator. Okay, so it's really just finding those standard deviations. We already know their means, both of their means. But they tell us that if the terathrills, which I'll just call T, if the terathrills one is double the standard deviation of the intimidator, then we need to calculate the interval for one standard deviation about the mean for the terathrills. So we need to calculate this for the terathrills. So the goal is to eventually find out this, okay, to find out the standard deviation about the mean for terathrills, meaning you have the mean, you only need the standard deviation of the terathrills. Okay, so that's all we're looking for, the standard deviation of terathrills. Let's go ahead and use what they gave us. Since we know that two standard deviations about the mean for the intimidator are these, it means that you need to take the mean minus two standard deviation, and it should give you 4.8. Okay, and we can actually use this to find the standard deviation of that ride, okay, specifically that intimidator first of all. So let's go ahead and calculate this. Well, we know the mean is, they told us the mean for the intimidator, since this is the intimidator's data that we have here. Okay, since they told us that, we're going to go ahead and take that mean, 13.20, right, and substitute it in place of the mean. So I'm saying minus two standard deviations is equal to 4.8. So let's solve for the standard deviation. You can take your negative two standard deviation over, so it becomes positive two standard deviation, and you have 13.20 minus 4.8. So we can actually just calculate that here. So 13.20 minus 4.8, which is 8.4, is equal to two standard deviations. Then if you divide both sides by 2 to find that standard deviation, then that's going to give us, so our answer divided by 2 gives us 4.2. Okay, now the reason I'm not just going to go ahead and run with this and say, yes, this is my answer, is because they gave us the interval, okay, for two standard deviations about the mean for that intimidator ride. Okay, intimidator, they told us that. Now, I can't just use one of it. I have to ensure that this is actually true. Since we have both the intervals, we have both values, okay? So I'm going to also do the same thing for here. If this is really the standard deviation, it should also work out here as well. So if I say the mean plus two standard deviations is equal to this number, 9.2, I should end up with that same standard deviation value. So let's go ahead and do that. The mean, again, is still 13.20, right? And we're saying plus two standard deviations is equal to 9.2. And if we say two standard deviations, leave that alone, and you say 9.2 minus 13.20, because we're taking that over, you can already see this is going to be negative, and I can already see it's not going to work out properly. So if you say 9.2 minus 13.2, because that's really what they are, 20, okay, it's the same thing as 2 in this case because it's a decimal. It's negative 4 that we get. And if you divide both sides by 2, your standard deviation here is -2. So I can already see that the standard deviations are not the same. So something is wrong with this interval. The interval is not correct because the standard deviation is not consistent. So there might be a mistake in this question because they didn't really ask us to find out whether this was the interval. They told us find one standard deviation about the mean for pterodrills. So I think this might have been an error, maybe. Okay, but you would still have to kind of do this to show them that you are using the information that they gave you to find what they asked you to find. So I'll just tell them that the interval for this, okay, 2 standard deviation interval about the mean is incorrect as the standard deviation is inconsistent. It's not consistent. It's not the same. It's supposed to be the same. Since it's one specific interval we're referring to, the standard deviation must be the same thing there. Okay, so that's what I'm going to just tell them in conclusion. So my conclusion is the calculation of the 2 standard deviations interval about the mean for the intimidator is incorrect because 2 different standard deviations were used. So we can see that they were not the same. Because of that, we can't really calculate anything because anything we calculate is just going to be incorrect. Okay, so there's no calculation can be done. Okay, no calculation can be done finally. So that is it for question 2. Okay, 2.2. There's nothing we can do there, but you get the idea. We're just supposed to find this, and knowing that the pterodrills, right? Okay, that standard deviation was double of that. Okay, we could have used that to finally find out the interval for 1 standard deviation about the mean. But we can't in this case because there's an inconsistency here. So question 1 says, truck drivers travel a certain distance and have a rest before traveling further. A driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes before he continued his journey. The information is given in the table below. And so, as you can see, as our variables, our x variables, we have the distance traveled in kilometers and then the amount of time that the driver rested for. Okay, so in minutes. So basically, they're really just trying to see if the distance that he travels affects the amount of time he's going to use to rest. And then, of course, with that kind of information, we can find out things like if he travels a specific distance, how long is he going to rest for? Okay, so the first question is 1.1, determine the equation of the least squares regression line for the data. Okay, so let's go ahead and fill this information in. Also, please just note, guys, that I am using this calculator from the Play Store. So you can use your calculator. This one is different, but I will, again, also just show you the steps as well on a Casio calculator. So to fill in this information, what we're going to go ahead and do is press mode on your calculator. You're just going to press mode, and then you're going to see some options. Go ahead and choose the option that says stat. So go for stat, and when you choose stat, you're going to see that option 1 says VAR. We're not looking for 1 variable data. We're looking for 2 variable data with bivariate, and you're going to go for option 2 that says A plus BX. Okay, so go for option 2 and it'll give you 2 columns. So mine is a little different. I kind of just have to scroll through and go to the data side, and then I'm going to go ahead and choose A plus BX. Okay, so I already had info recorded. It always does that. So we're going to go ahead and fill this in. On the x-axis or the x column, you're going to fill in all your x values, and the y's, fill in all your y values. Okay, so now that we have all the information filled in, what we're going to go ahead and do is we need to think about what exactly the least squares regression line looks like. What does that equation look like? Well, the equation for the least squares regression line is really the equation of a straight line, and its formula is y is equal to a plus bx. So really all we need to find is the value of a and the value of b. So now that everything is recorded onto our calculator, how we will find that is like this. So to record your data, you're going to press AC, Shift, and 1 on your calculator. And once you have pressed that, you're going to go ahead and go for option 5, which says REG for regression. My option 5 is over here, so I'll just go to regression. And then once you choose that, you will see 5 options. So you can see that there's one for A and there's also one for B as well. Let's go ahead and find out what exactly A is. So you're going to go for A and then you press equal to so that it shows you the value of A. And that is negative 23.85 rounded off to 2 decimal places, so 85. And then there we got that. Then to find B, you're going to go ahead and press Shift and 1 again to get your data back. For me, I have to erase that first and then Shift 1 so I can get my data back. Then again, we're going for option 5 because we're really just trying to find variables that have to do with the regression line. So option 5 for regression. And then you're going to go ahead and go for B and say B, and that is option 2 on your side, and just say that is equal to, and then you're going to go ahead and get 0.20, and that rounds off to 2 decimal places, so that rounds up, and that is going to be 23. Okay, so that's what we have for A and B. So it means that the equation of our least squares regression line is therefore y equals A value is negative 23.85 plus our B value is 0.23, and then we have x, and that is the equation of the least squares regression line. Okay, moving on to the next question. Okay, 1.2 says, if a truck driver traveled 550 kilometers, predict the amount of time in minutes that he should rest before continuing his journey. Okay, so just like what I said in the beginning, once we find the equation of the least squares regression line, and when we're using this data, we can really just use it to make predictions, like how long he's going to rest if he travels a specific distance, or if he rested a specific distance, what exactly was the kilometers he traveled. Okay, we can use that to make those types of predictions. So now we're going to have to really just look at what exactly they have given us and what they're asking us for. They said that the truck driver traveled for 550 kilometers. So you're going to have to think about that. The traveling distance, right? Were those the X or Y values? Where does that belong? That is, as you can see, kilometers. Those are our X values. So it means that they have given us an X value and they clearly want us to find a Y value, because the question is they want us to predict the amount of time in minutes. The time belongs to our Y values. Okay, so because we have the equation of our least squares regression line, we can use that to make those predictions. Okay, so let's go ahead and do that. We're going to say y is equal to, so now we know that this is just an X value. We will take that number and substitute it into X. So y equals negative 23.85 plus 0.23, and then in place of X, we're going to go ahead and substitute the 550. Okay, now the great thing about these statistics is you will not lose your data, okay, if you use your calculator. You can just go ahead and press AC to just remove the number that is already written there, and then you can actually punch in this on your calculator and it should be fine. So we'll say negative 23.85 plus 0.23, and then in brackets 550. And you see what it gives us. It gives us 102.65. Okay, so there we go. And this, of course, is in minutes. You don't really have to round off. It's fine like that. So that is our answer. Okay, moving on to the next question. The next question, 1.3, is write down the correlation coefficient for the data. So the correlation coefficient is that value of R. Okay, and that R really just tells you the type of relationship that you have between your data. It tells you whether your data has a strong relationship or whether it has a weak relationship. And really all this means is if the relationship between your data is strong, for example, all this means is that you can actually rely on the data. In this situation, what we would mean by that, because we see that on the x-axis, we have the distance that is traveled in kilometers, and on the y, we have the time it takes for this driver to actually rest after traveling a specific distance. We're really just trying to see, does the distance he travels affect the time he takes to rest. Okay, so if it has a strong relationship, then it means that yes, we can highly depend on that. So if the correlation is strong, we can actually agree and say, yes, it means that the distance that he travels actually does affect the amount of time that it takes for him to rest. So, of course, with that being said, you will have some data where there's absolutely no correlation at all. Okay, so that's just a little explanation on what that R really means. So to go ahead and find that, what we're going to do is on our calculator, again, you can press AC just to remove that data, Shift and 1. I actually have to press AC. You don't have to. On the Casio, it's already naturally programmed to not kind of take the number you last wrote and then multiply it. Mine does that for some reason. And when you press that, you're going to have to go for option 5 again for regression. And then you see that option 3 is R. So you click on number 3 and say is equal to, and you see that R, round off to 2 decimal places, is 0.98. Okay, so that is all they asked us for there. Moving on to the next question. The next question, 1.4, says interpret your answer for question 1.3. So given an interpretation, you're really just commenting on the correlation coefficient. What type of relationship do we have between our variables, okay, our X and Y variables? What we're going to do there is you can look at the correlation like this. So I try to explain it as a number line. Now, if you have, for example, a correlation of 0, then this means a correlation coefficient of 0. This means there's absolutely no relationship whatsoever between the X and Y values. So in this situation, what that means is the distance that he travels and the time he takes to rest has absolutely nothing to do with each other. It's just completely random. So that is what that would mean if our correlation coefficient was 0. There's no correlation. And then if your correlation was 1, positive 1, right? What that means is that this is a perfect correlation. It's perfect and it's also positive. So how we look at it is we say the strength and the whether it's positive or negative. So that would be a perfect positive correlation. In that case, that would mean without a doubt, the distance that he travels actually highly affects or perfectly affects the amount of time that it takes for him to rest. Okay. And then if it, of course, was -1, it would still be perfect. The only difference here is that you just have a negative value. So in this case, that will be perfect negative. This will be perfect positive. And then if it was in between like 0.5, for example, as you can see, this is positive. This would be moderate, meaning there's a 50% chance that, it actually has a correlation. So there's a 50% chance that the distance that he travels affects the amount of time that it takes for him to rest. And then if it was between here, like 0.2, for example, this is quite weak. This is a weak, of course, it's positive. So weak positive correlation, that means it doesn't even really affect it. You can't really rely on that. You can't say that, okay, the distance that he travels actually affects the amount of time that it takes to rest. And then if it was between here, like in the 0.90s, I'll call it 0.9, right? Then that is actually strong. So that's strong positive, okay? And we also have all of these same things here for the negatives. They're just going to be, for example, a negative 0.2 would be a weak negative correlation here, and so on. So when it's positive or negative, it doesn't affect the strength. That is just telling you the way the data generally goes. So your data doesn't necessarily form a straight line. However, you can draw like a straight line in between the data, which is called our line of best fit. So all that means is if we have positive, right? If our correlation is positive, it just means that your data is generally increasing. So that's what I mean by it doesn't form a perfectly straight line. However, the information is generally increasing. If it's negative, it's generally decreasing. Okay, so that was just a little explanation on how the correlation coefficient works. And so when we look at a correlation coefficient of 0.98, that would be within where? That would be within here, which is strong. So this is a strong positive correlation. And that's all you have to tell them. You don't have to start giving them explanations and saying, yes, that means that the distance that he travels actually highly affects the amount of time he's going to rest. You don't have to say that. You can just tell them what the correlation is, which is a strong positive correlation. So that's all. Positive correlation. So that's all. Okay, so that is it for 1.4, and we move on to 1.5. We move on to 1.5, and it says, at each stop, the truck driver spent money buying food and other refreshments. The amount spent in rands is given in the table below. Okay, so this is a new data. Yes, it is about the same story, but it's a new data. So we have 1, 2, 3, 4, 5, 6, 7, 8 values again, because it's still these 8 trips that they spoke about initially. So we have to calculate the mean amount of money he spent at each tuck shop. Okay, so for these types of questions, grade 12s, I want you to note that you can actually use 2 methods. You can actually take these values and actually find the mean by adding up all the values that you have and then dividing it by the total number of values, the frequency, right? Or you can actually use your calculator to do this. Okay, go into the stat option. You will still get the full 2 marks for this. And you'll know this if you check 2022's November paper. They do award for full mark. So answer only still gets the full marks for this type of question if they ask you for the mean. Okay, so I'm not just going to go ahead and add it up. I'm going to go ahead and record it because I know they're going to ask us other questions about other variables in this data set. So let's go ahead and record this data. So our data may have still been on this. You can actually just get rid of it by removing it AC, and then you're just going to go ahead and press mode and go for the option that says comp. I think that is going to be option 1 on your calculator. So you just have to go for that. So I'm just going to go back. And then we're going to go ahead and press mode again because we need to record this data. So mode, and then go for option 2, which is going to say stat. Once you go for that, this time we're not going to go for the option that says a plus bx, because as you can see, we're working with a data set that only has 1 variable. So go for 1 VAR. So that is option 1 on your calculator. So on my calculator, that is 1 VAR over there. I still have data recorded. I just have to get rid of it. So you're just going to go ahead and put down these 8 values that you have. And once you have everything recorded, you can go ahead and press AC, Shift and 1. And once you press that, you're going to go ahead and go for option 4 that says VAR, option 4. And when you go to that, mine is over here, you're going to find the mean. As you can see, there's the mean, okay? It is that symbol. So go for number 2 and say equals, and you will see that your mean is 150. Okay, so that is our mean. Now, remember, this is money in rand, so we need to say our mean is 115 rand. So that is, it just means that he spent on average 150. Okay, the next question. Moving on to the next question. Then the next question, 1.5.2, is calculate the standard deviation for the data. So now we have to find the standard deviation. So it's good that we actually recorded the data down because we need to use that data to find the standard deviation. You can find the standard deviation by yourself, but I would never advise you do that for 1 mark. Okay, so to find that standard deviation on your calculator, you can just press Shift and 1. I have to delete this first, then press Shift and 1. And then when our data comes up, you're going to go again for option 4, variable. And once you are there, you're going to choose the standard deviation option, which looks like that. Okay, so standard deviation of your X values. That is going to be option 3 and say equal to. And you will see that your answer is in decimals. So it is still money. So it's 50 rand, and well, that 7 will round up and turn that 9 into 10 cents. And then that's going to add to the 4 and create a 5. So that is 50 rand 50 cents. That is what the standard deviation is going to be. Okay, a quick explanation of what the standard deviation actually is. It is it's a mean value, yes, but it's a mean value or an average of, we're looking at the mean, right? And then you're looking at all the values, and some values are going to be greater than the mean and some values will be less than the mean. And what the standard deviation really just does is it calculates the difference, okay? So like from the mean to this value, for example, how far apart are they, right? And from the mean to this, how far apart are they? And what it does is it gets the average of those differences. So it is an average, but it's really the average of how far apart these values are from the mean. That's why we say it's a measure of, it measures the spread of the data. Now, the calculation doesn't actually go like that. That's just like a brief explanation of what that is. Okay, so that is our answer for that question. The standard deviation is 50 Rand 50 cents. Moving on to the next question. So the last question for question 1 is, at how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? Okay, so we have worked on questions like these in the past already. So you're going to have to think about it like this. They want you to tell them how many stops are you going to have in this data, right? That is going to be less than 1 standard deviation below the mean. So let's first focus on finding out what exactly 1 standard deviation below the mean looks like. So you're thinking about that. It means you have the mean and you need to just go a standard deviation lower than the mean. Okay, if you're going 1 standard deviation below the mean, it means the mean has this value and you're removing a standard deviation from it, okay, to go a standard deviation below the mean. If you were trying to go a standard deviation above the mean, then you're looking at the mean and you're just going 1 standard deviation above the mean, so you're adding a standard deviation there. Okay, so here mean minus standard deviation is going to get us to that 1 standard deviation below the mean. So that's going to be, our mean is 150 and our standard deviation is 50.50. So, well, 150 minus 50 is already 100 Rand, and then 100 Rand minus 50 cents is 99 Rand 50 cents. You can also do the calculation on your calculator. It won't affect your data. So that covers this part that speaks about 1 standard deviation below the mean. Then we still need to find out how many stops exactly, right, is going to be less than this value, that 1 standard deviation below the mean. So how many values are less than this in our data set? Well, as you can see, we can only have 1 value that is less than that. Everything else is above 99 Rand 50 cents. So it means our final answer is, when they ask us at how many stops did the driver spend an amount that was less than 1 standard deviation, it was only 1 stop. So that is our answer there. At how many stops? Just 1. Okay, so there we go. That is it for question 1. And then we move on to question 2, which has more statistics. Okay, we're on question 2, and question 2 says, at a certain school, the staff committee wanted to determine how many glasses of water the staff members drank during a school day. All teachers present on a specific day were interviewed. The information is shown in the table below. So this is the information that we have. So we have on the right the number of glasses of water drank per day, and these are in groups, okay? So people who drank between 0 to 2 glasses of water, there were 5 people, and then people who drank between 2 to 4 glasses, there were 15 people, and so on. So the first question is, complete the cumulative frequency column provided in the answer book. I don't have an answer book, so I'm just going to create a column here for the cumulative frequency. Okay, so how we complete the cumulative frequency column is like this. You're just going to go ahead and take the first number, and we're really just dragging it to this side. So we have 5. And then to get the next number, you are saying this number that you have, you're going to add 15 to it. So 5 plus 15 gives us 20. And then to get the next number, you're going to say the 20 plus the 13. And that gives you 33. And then 33 plus 5 gives you 38. And lastly, we have 38 plus 2, which gives us 40. And that's how we calculate our cumulative frequency. Very simple. So there's our cumulative frequency done. Moving on to the next question. And 2.2 says, how many staff members were interviewed? So in total, how many staff members did we have in this study? There were a total of 40, because now we can see the total number of staff members because we filled the cumulative frequency. So there are 40 staff members. Okay, moving on to the next question. The next question, 2.3, says, how many staff members drank fewer than 6 glasses of water during the school day? So to find them, we can actually look at them like this. So when you look within the first class, these teachers here drank glasses of water that were between 1 to 2, okay? Not really 2 exactly, but less than 2. So these, right, there were 5 people in this category. We need to find out the teachers who drank fewer than 6 glasses. So fewer than 6. So if this is fewer than 2, then this would be fewer than 6, okay, or less than 6 glasses. So how many teachers drank water between here? If you're looking at the class, right, the teachers who drank water within this class is 13. Yeah, that's like 4 to 6. So that is 4 to 6 glasses, right, is exactly 13. But they didn't ask you for 4 to 6 glasses. They specifically asked for the total staff members that drank fewer than 6 glasses. So as long as it's less than 6, you take it. So that means you have to take the total teachers in this class and the total teachers in this class as well, because that's fewer than 6. And even here. So really what you're going to do is, instead of adding these, you know that the number that you're going to get here belongs to everything that is in these classes. Okay, so we're going to actually say that's actually 33 teachers that drank fewer than 6 glasses, because if you added these up together, you would indeed get 33. So the cumulative frequency in this situation would have helped us to find that. So that is a total of 33 staff members. Okay, moving on to the next question. Then question 2.4 says, the staff committee observed that K teachers were absent on the day of the interviews. It was found that half of these K teachers drank from 0 to fewer than 2. Okay, that is that glasses of water per day, while the remainder of them drank from 4 to fewer than 6, which is in that class, glasses of water per day. So let's actually just go ahead and break that down. What they're saying is, it was found that half of the K teachers, if you think about what half of the K teachers are, that's just really K over 2, or you could see that as a half K. So they're saying out of the total K teachers that were absent, half of them, right, fell into this category of 0 to 2 glasses of water. And then they said, while the remainder of them, so the remaining part of half K, the remaining part of half K would be a half K again, because if you add a half K and a half K, they give you the total K. So the remainder, so the half K, the other teachers, they drank within this class. That's really what they're saying. So we're going to have to do some reconstruction with the data that we have. We're going to have to add to certain staff members here. And what they tell us is, when these K teachers are included in the data, the estimated mean is 4 glasses of water per staff member. So they tell us exactly what the estimated mean is when we finally add the missing teachers. And then now the question is, how many teachers were absent on the day of the interview? So ultimately, they want you to find what? Remember how they told us that the staff committee observed that K teachers were absent. So they're actually just asking you to find the people who are absent, the teachers absent, which is K. That's what they want us to do. So find the value of K given everything they have told us. Okay, so we're going to need to reconstruct the table that we have here. So I'm just going to take this and we're going to really use this. We don't really need the cumulative frequency for this. We only need the staff members because we need to add certain things to the staff members. Okay, so remember that we had here half of the K teachers, K over 2 or half K, right? They drank within this interval. So we're going to go to the 0 to 2 glasses per day. And we know that the teachers here are not just going to be 5 anymore. We still need to add that half K teachers here. So we're going to add, you can say a half K, you can say K over 2, it's still fine. I'll actually just take that as K over 2. It's still the same as a half K, okay? Because that K is just going on the numerator to multiply into the 1. And then the other teachers, where were they? The remaining teachers, K over 2 again, they were in this interval 4 to 6. So we go to the 4 to 6 and we're going to put them in there. So add the K over 2 here. And the question they want us to do is find K if they told us that the estimated mean is 4. So because they told you what the estimated mean is, you have to use the calculation for the estimated mean to actually find the value of K. That's the only thing that we can do. It would have been really nice to just use maybe the total number of teachers, but unfortunately we don't know what K is. So we don't know how many teachers there are in total anymore. There used to be 40 teachers, but now these Ks have been added, so we don't know how many teachers they are. So we're going to use the estimated mean calculation, and this is how we calculate that. So I'm going to go ahead and write down these values. Let us look at these because as you can see, they do say X is greater than. So we'll call these our X values. So what we're going to do is first of all find the midpoint of our X values. So let's find the midpoint of X. That's going to be a table on its own. And then on the other side, we're going to still take the number of teachers, the number of staff members. And this is a table that we're going to have. We will have more things over here, one more column. Let's go ahead and put down what we have. So the idea behind finding the estimated mean, because that's what we're trying to do, we're using the estimated mean calculation to find the value of K. The idea behind finding the estimated mean, it's still the same thing as finding the mean. But you know how with the mean, they give you values, right? They can give you like 2 and 5 and 7 and 21 and 24, for example. And then you would take all these values, add them up together, find the sum of the values, and then you would divide by the frequency, right? The number of values that you have. Well, unfortunately, in group data, we don't have single values, okay? So because we don't have single values, we're just going to have to make little adjustments. What group data is really doing is, instead of taking all these numbers out separately, because then we'll have a whole lot of values. We'll have a whole lot of glasses of water per day, because that's the main point, right? The water that we have. How many teachers drank specific glasses of water? Instead of you going to these 5 teachers and asking, how many glasses of water did you drink specifically in this day? And then this teacher says, I drank 1 glass of water. And how many glasses of water did you drink? I drank 0 glasses of water. Instead of taking all of those, we have just grouped them together. So because we don't have them out like single numbers like these ones, what we do is we're going to estimate. And the estimation starts from here, where instead of taking these values separately as, oh, there's 1 glass of water and there's maybe 0 glasses of water in this class, what we're going to do is actually add these two together, these numbers together, and then divide them by 2. So that's where we're already creating the estimation. So we're really saying everybody here is going to really just drink this amount of glasses. You take the first value plus the second value and you divide it by 2. 0 plus 2 is 2. 2 over 2 is 1. So we're just saying everybody here drank 1 glass of water. It's an estimation. And that's how we find that midpoint. That's what we're going to do here. We're saying that 0 plus 2 over 2, which gave us 1. Okay, everybody in that line drank 1 glass of water. And we know that there were 5 staff members there. Then the second one again, 2 plus 4 over 2. So 2 plus 4 over 2, 2 plus 4 is 6 over 2 gives you 3. And we know that there were a total of 15. So we're saying all these 15 staff members, we're going to pretend they all drank 3 glasses of water, estimating, okay? And then we're going to go ahead and add these. 4 plus 6 is 10. 10 over 2 gives you 5. And we know how many teachers were there. That was, and I'm forgetting something. So we already added the plus K over 2. We need to include those in our calculations as well. So K over 2 needs to be there. 5 plus K over 2 is the total number of teachers that drank 1 glass of water, an estimate of 1 glass of water. And then over here, that would be 13 plus K over 2. That's the total amount of teachers that we have that drank an estimate of 5 glasses of water. So plus K over 2. And then we'll do the same for the rest. 6 plus 8 gives you 14. 14 divided by 2 is 7. So that's 7. And then you have your frequency, which is 5. And then the last one, we're saying 8 plus 10 is 18 divided by 2 is 9. And that is 2. There are 2 teachers within that category. So now we're just saying that an estimate of 9 glasses of water was drank by 2 teachers. An estimate of 7 glasses of water was drank by 5 teachers. Okay, we have roughly estimated the X values instead of asking each teacher. So here's the thing about it. Now that we have these as estimates to find the mean, you're probably going to think, oh, okay, fine. Why don't we just go ahead and, like we would have done here, add our X values and divide by the total number of teachers that we have? Yes, that's what we're going to do, but we can't do that from here. The reason why is because you cannot just say, oh, we're going to add 1 and then the 3 and then the 5, because this is 1 glass of water, yes. But how many teachers drank 1 glass of water? An estimate of 1 glass of water. That is 5 plus k over 2 teachers. Okay, so if it was just, for example, like this one, this is easier to look at. If we're looking at it like this here, we're saying that we had 15 teachers who drank 3 glasses of water. If you are actually adding that up to find the mean, it wouldn't just be, okay, just take the 3 and add it to everything else. There are 15 teachers that drank this amount of water, meaning you're going to write 3, 3, 3, 3. You're going to have to add 3 15 times. Okay, so instead of doing all of that, what we're going to do is we'll take the midpoint and multiply it by the frequency. That is to get the total amount of water, the glasses of water that was drank by the teachers in each category. So that's where we do this. We're going to take the midpoint of the X values and we're going to multiply that by the number, the staff members. Okay, so that is the 1 multiplied by, and our staff members here is 5 plus k over 2. We're just going to have to take it like that. Well, the nice thing about this is 1 times this will just stay 5 plus k over 2. So let's keep that in mind. Then to find here the total glasses of water that was drank here, it is we know that there was 3 glasses of water, but 15 teachers drank. So that is 3 times 15, which is 45. 45 glasses of water was drank in this category in total. And then over here again, midpoint times frequency. So 5 multiplied by, we have 2 terms here, so 13 plus k over 2. And then here 5 times 7, that is 35. And lastly, 9 times 2 gives you 18. Okay, so this is what we have now. And now we have all our total glasses of water. Just like we would have done here, when calculating the mean, you take all the variables that you have, you add them together and you divide by the number of variables. That's what we're going to do here. So we now know the total glasses of water that was drank, and we're going to add all of that up together. So that is the main calculation we're going to have there. So let's go ahead and add all of that. Okay, so the sum, we're going to say how we calculate the mean is by saying the sum of our midpoint, right? The midpoint of the X values multiplied by the number of staff members, right? All of that. Add all of those together, and then we're going to divide by the number of staff members. That's how to find the mean in this case. So this is equal to, now the thing is we know the mean. So this is going to create an equation really, because we're trying to solve for k. That's the main point. That's the main goal. So therefore, the mean was what? What did they tell us that the mean was? The estimated mean they calculated was 4. So in place of mean, we're saying 4 is equal to, and let's go ahead and add up those together. So we're adding these up together. So 1 times this stays the same. So that is still 5 plus k over 2 that we have there. And I'll just leave that in red because we're trying to solve for k really. And then we're saying plus the next value we have 45 glasses of water there. And then the next one plus, we're saying 5 times 13 plus k over 2. And then plus the 35. And then plus the 18. And we're going to divide all of this by the total amount of staff members that we had. Now we can actually find that over here. You see that we can actually add these together and then find that. So I guess this one we can just do on screen. So 15 plus, let's just add the simple numbers first. So since these ones are on their own, 15 plus 5 is 20, plus 2 is 22. So we'll have 22. Then 22 plus 5 is 27, because that's that 5 there. And then plus the 13 gives you 40. So you still have 40 there, but then you have the k over 2 and the k over 2 that we still need to add together. So k over 2 plus k over 2 gives you k, okay, because it's really a half k plus a half k, which gives you a whole k. So that is what we have there, 40 plus k as our total number of staff. Now we just have to solve for x in this equation that we have built up. Let's go ahead and add the numbers that are just on their own first of all. So the 5 and the 45 gives you 50, plus the 35 would give you 85. So let's just put that down. We say 4 is equal to, and we have 85. Okay, but we still have that plus 18. So 85 plus 18. So 80 plus 10 is 90. So 95 plus 8 is 103. So we're going to have 103 there, and then so that's all our numbers added, and then we're going to go ahead and add the k's that we see. So you see that you just have, first of all, plus k over 2, that one in red, but then this we still have to simplify that because that still has to be FOILed. Okay, let's go ahead and just distribute here. 5 multiplied by 13, so 5 times 13 is going to be 13 times 10 is 130, so half of that is 65. So that's plus 65, and then we're going to multiply that. So we're just distributing. So 5 times k over 2, that's going to be, you see, 5 times k over 2, you just multiply numerator and denominator. So the denominator here is 1, so that just gives you 5k over 2. So that's what we have there. Okay, so we're going to have to add our k's together as well. And this goes all over 40 plus k. Okay, so now that we have this, we can go ahead and, well, we still have two things to add there. So 4 is equal to 103 plus 65 is 168. And we have our k's. So let's add our k's together. Do you see that the denominators are the same? So if the denominators are the same, just add your numerators. K plus 5k gives you 6k over 2. 6k over 2 can be simplified. 6 divided by 2 is 3. So this is actually 3k. So that's what we have there. We're going to actually just solve for k. So divided by 40 plus k. Okay, we have this equation. We're trying to solve for k, but you have a 4 on this side and you have a fraction here. So why don't you put this as a fraction, rewrite that as a fraction, and then we can cross multiply. So we're going to multiply the 4 with that and then the 1 with that. Okay, so we're going to say 4 times 40, because you need to multiply the 4 to the 40 and the k. 4 times 40, 4 times 4 is 16. So that gives you 160. And then 4 times k is positive 4k that we have. Is equal to, and then cross multiply like that. 1 times 168, it basically just stays all the same. 168 plus 3k. Okay, now that we have that, we can just solve for k. Put the k's on one side, you've got 4k here, and the 3k comes over and becomes a minus 3k, 168, and you have 160 here, bring that over and it becomes negative. So therefore, k is finally equal to 168 minus 160 is 8, and that is our answer. So k is equal to 8. So what does that mean? The question was, how many teachers were absent on the day of the interviews? That was the k value, right? So it means that there were 8 teachers absent. Make sure to always answer them. The total is 8 teachers. Okay, and that is our answer. So grade 12, you need to just really look at the things they give you and what exactly they're asking you for. Because they gave us the estimated mean, I knew that we have to use the estimated mean calculation to actually find this. So, and now you see a way that you can actually find the estimated mean. This is not always asked a lot in grade 12. In fact, I've only seen it in November papers. I've only seen this being asked twice. However, there's definitely more times. It's just from the papers that I've seen. So make sure you study everything from grade 11 and grade 12. All those concepts are very important. So we have question 1, and it says, the number of pages in 10 A4 books and their corresponding weights in grams are given in the table below. The data is also represented in the scatter plot. Okay, so they already gave us a scatter plot. We don't have to plot things down. And of course, we have our x and our y variables. So the first question says we need to determine the equation of the least squares regression line. So the equation of the least squares regression line looks like this. It is y is equal to a plus bx. So as you can see, it looks like the equation of a straight line, and the only things that we actually have to find is the value of a and the value of b. So in order to find those, all we're going to do is use this information that we have here. So on your calculator, this is what you're going to do. Okay, so on your calculator, you are just going to go ahead and press mode, and then you're going to choose the option that says stat. My calculator is a bit different, so my number 3 says stat. So I'm going to go for stat. And then you're going to see that in option 2, you will have something that says a plus bx. That is your equation of your least squares regression line. We go for option 2. Then we have 2 columns. By the x, fill in your x values, and by the y, fill in your y values. Okay, and once you filled it in, you see that the number that we have over here is 10, showing us that we have exactly 10 numbers. Okay, so after filling that in, you can go over to the y-axis, okay, the y column, and you can go ahead and fill in the values that you have in your y values. Okay, and now these values are in. So there, you see that we also add at 10. So after putting the values in, to record this data, you're going to press, first of all, AC, then Shift, and then 1, okay? Then now, because we are looking for the equation of the least squares regression line, you're going to go for number 5, which says REG for regression. And as you can see that we have A and we have B. So to find the value of A, we say 1 is equal to, okay, so now that we know our A value is negative 43.72. So now we need to find our B value. So while on your calculator, you can just go ahead and press Shift and 1, and then again we'll go to number 5 for regression, and we want the B value, so we choose option 2 and say is equal to, and you see that B is 2.36 rounded off to 2 decimal places. So it means that the equation of your least squares regression line is y is equal to, our A value is negative, so that's negative 43.72, and then our B value is positive, so it's plus 2.36x, and that is our answer. Okay, so moving on to the next question 1.2, which says draw the least squares regression line on the scatter plot in the answer book. So we have to draw that line on here. I'm going to just use this because I don't really have that answer book. So this is what we're going to use. Now, there's 2 main points that you usually need in order to draw the least squares regression line. Those points, first of all, is the y-intercept and your mean point. So that would be the mean of your x values and the mean of your y values. The y-intercept is simply just found by making x equal to 0. So if you look at the equation of your least squares regression line, if you made x equal to 0, that whole thing becomes 0. You'll see that you'll just be left with this, okay? Because it is the y-intercept. It's c in the equation of y equals mx plus c, okay? So it's the only thing without an x. But the thing about this, and the reason I can't really take this, you have to also look at it within the context of what's been represented, okay? What are we actually looking at here? In this situation, the study is based on the number of pages, okay, in 10 A4 books and their corresponding weights. If we can see that this value, the y-intercept, which is a y value, if the y value is negative, the y values that we have here is the weights. We can't have a negative weight. And you also notice that they don't have any data for here. So it means we didn't have any books with pages like 20 pages and 40 and so on. So we can't really find that. So instead of using the y-intercept in this case, we're not going to use that. We'll just use the mean point. Also, when you're finding the y-intercept, you're making x equal to 0. The x are the number of pages. If you have no pages, then there are no books. Okay, so there's nothing two-way. So we're only going to use the mean point. Okay, so we're going to use the calculator to find the mean point. So that is just the mean of the x values and the mean of the y values. So to find the mean of the x values, we're just going to go ahead and go onto our calculator, and you can go ahead and just press shift 1. But this time we're not going to go to regression. We're going to go to number 4, okay, and go to option 4, and now you see what we have, the information about the variables that we have. You see that number 2 here for my number 2, okay? That is the symbol for mean. That's the mean of the x values. So say 2 is equal to, and you see that the mean of our x values is 120. Then we're going to do the same to find the mean of the y values. So let's find the mean of, let me just put it like that, y values. So I'm going to go ahead and say shift 1 again to get this information. Go to number 4, and then I go and find that this is in option 5, the mean of the y values. And we get 239.5. Okay, so our mean point is 120 and 239.5. And that's what we're going to plot. So we'll go on a Cartesian plane, go to 120. I'll just put this in like a, standing out color. So 120 and then 239.5. So 120, then this is 200 here. And then we need to go to 239. Okay, so just try your best to find that point. Okay, so you'll notice that I put lines marking so that I'll remember exactly where each number is and I'll be able to properly measure. So that 239.5, you see that we have 250, or we can even start from 200. I noticed that this is actually counting in intervals of 10. So it's like 200, 210, 20, 30, 40, 50. So we're just going to 10, 20, 30, 40, and we're really just here, very close to this line, but just a little below. So we have 120 and just a little below it. Okay, so I might as well just put it on the line. But the important thing is that you label that point. So that is the 120 and the 239.5. Okay, that's the mean point that we have there. And then now to draw it, I know it looks so weird and it's kind of like, how do I actually draw this now since I don't even have that y-intercept? Well, you can still draw it, but it's just going to be a little different. So with reference to what that y-intercept would have looked like, since it would have been 0 and negative 43.72, I'm just going to see that it would have been, since the x value is 0, right, has an x value of 0, and then a y value of negative 43.72. That would have been somewhere like, see, this is 50, so it would have somewhere like down here. It would have been somewhere there, right? It would have looked something like this. So your goal is really, in a situation where you have your y-intercept, your goal would be to connect the mean point and the y-intercept, okay? Don't worry too much about trying your best to join the lines. That's not really what we're doing, because the line of best fit is a line that is really joined by the y-intercept and then the mean points. Then you'll notice that the points may be close to that line of best fit or far away from it, depending on the correlation that you have. So if it has a strong correlation, you'll notice that the points are closer to it. And if it has a weaker one, the points will be further away from it. Okay, so what I'm going to do is I'm really just going to erase these because I don't really need that. That's not there in the situation. Okay, so because I know I don't have any data here, I'm just going to really do that. And so that's my line of best fit. So even if a new point had to come in, I'll be able to see whether this point is closer to the line or further away from the line, and you'll be able to spot things like outliers as well. Okay, so that is the answer to that, and we finally move on to the next question. 1.3 says, predict the weight of an A4 book that has 110 pages. Okay, so let's think about it like this. We're going to predict. Well, we already have the line of best fit. We can use that to make predictions, okay? Remember, it's not going to give you an accurate answer. The reason why is because this is sort of like a real life experiment going on. Someone is taking books and measuring the amount of pages they have and then weighing it and seeing how that corresponds. Okay, so even the answer we get in the line of best fit and the answer that you get in the equation, they're both still predictions. So I'm going to use the equation of the line of best fit, and all you have to do here is because they asked for you to predict the weight, okay, of an A4 book that has 110 pages. Do you see that in your data, your pages are your X values? So it means they've given you an X value and you need to substitute it into your equation to get a corresponding Y value. So go ahead and just say Y is equal to negative 43.72 plus 2.36, and then in place of X, say 110. So when we substitute this, we get 215.88. Now remember, the Y value is speaking about the weights, which of course can have decimals. So I'm going to leave it like that, 215.88, and this is measured in grams. So this is the amount of grams approximately that amount of pages will have. Okay, moving on to the next question. The next question, 1.4, says calculate the percentage weight increase. Okay, percentage weight increase between a book with 110 pages and a book with 130 pages. Okay, so this is really just calculating percentage increase. So this is the calculation for percentage increase. You're going to take the new amount that you got, right? And you're going to subtract it by the original amount. And you're going to divide that by the original amount. And it's really because we're just trying to compare the difference to the original amount. You're just seeing how different is it compared to what it used to be. So the new amounts that we would have is because they said a book with 110 pages with a book with 130 pages. So we'd have to take the one with 130 pages minus the one with 110 pages divided by the one with that. But remember, it's saying calculate the percentage of the weight increase. This is just the pages. Okay, so we know the approximate amount of grams, the weight of the 110 pages. So it means that first you have to find the weight of 130 pages. Now let's just check if we actually do have that information in our table. Do we? No, we only have 135. Okay, 135 pages will give you 250 grams. So we don't have that. We can as well just go ahead and find it. So you can use your calculator to do this. And you can just, in place of 110, let's just go ahead and substitute. So we're going to substitute 130 to find that. Okay, so is equal to, and we get 263.08. Okay, so those are the results. That is the weight. So let's take, first of all, the new weights that we have, which would be this 263.08. And then, and I notice now I didn't include a specific thing. This is just to find, well, this will not be the percentage yet. So you'd have to multiply to make it a percentage by 100. Okay, so that part. Okay, so we're saying 263.08 minus the original weights that we had, which was this one, okay, for the 110 pages. So that's 215.88, and then divided by the original, which is 215.88. Then just multiply that by 100 and it will give you the percentage increase. And there is my calculation. Okay, I put it back on comp. So to do that, you just press mode and then 1. Okay, so I put it back here just so that we can calculate. We don't even need the data anymore. This is the last question for this data. So that is equal to, so that is 21 points rounded off to 2 decimals, 86%. That is the percentage increase that we have there. Okay, so that is the last question that we have for question 1. And then we finally move on to question 2. Question 2 says 50 athletes need to access suitable training facilities. The table below shows the distance in kilometers that they need to travel to obtain access to suitable training facilities. Okay, so people are training and they're just showing the kilometers that they need to travel to reach these training facilities. So we have, the first question says, complete the cumulative frequency column provided in the table in the answer book. I don't have an answer book. I did manage to find graph paper though for the next question. So we'll work with that. With the cumulative frequency, what I'm going to do is I'll just write it here. Okay, so this is my cumulative frequency. Just leave it like that. So let's go ahead and fill that in. Okay, so this is our cumulative frequency column. And in order to fill this in, you're first of all just going to drag the first number over, and that is 3. And to get the next number, you say 3 plus the 7, and you get 10. And then 10 plus 20, and that's 30. 30 plus 12, and that's 42. 42 plus 5, and that's 47. And then 47 plus 3, and that is 50. So there we go. And that's how you fill in your cumulative frequency. Okay, next question, 2.2. Okay, 2.2 says, on the grid provided in the answer book, draw a cumulative frequency graph, which is an ogive, to represent the above data. Okay, so let's just get that graph paper. Okay, so this is our ogive that we're going to just draw. Here's our graph paper. So with the information that we have, please note that we're only going to be using this information, and that's your x values and the cumulative frequency, because this is a cumulative frequency graph. First and foremost, the number that you see here, and I've mentioned this before in my other videos as well, the number that you see here, right, that x value, the y value that is going to go with it must always be 0. So even if it was a 5 here, right, the x value will be 5 and the y value will be 0. But in this case, it's 0. So the first points that we're going to have would be this x value of 0 and our corresponding y value of 0 as well. So that's 0 and 0, and that will just go right there. Okay, we're done with that one. Then the next one is going to be the 5 and your cumulative frequency value of 3. See? So now it's just going to be the 5 with the 3, the 10 with the 10, the 15 with the 30, and so on. So we have 5 and 3. So that's 5 and 3. Then we have 10 and 10. So that's 10 and 10. And then we have 15 and 30. So that is the 15, and our 30 is over here, 30. And then 20 and 42. So that's 20 and 42. So here is 40. And then you just go, since this is intervals of 5, as we can see, so 41, 42. So 20 and 42 would be there. And then the second last one is 25 and 47. Okay, so that's 25. This is 42. So this is 45 here that we have. And then 47 is just 46, 47. So 25 and 47. And then lastly, it is 30 and 50. So that is 30, and then 50 is right over here. So we could just go 50 and then find 30. So there. Okay, so there we go. 30 and 50 is our last value. Then we're just going to join these points, and it's really just going to create a curve. So I'll just use another bright color. So let's use blue. You're going to just draw it, and it's going to be a curve like that and down on there. Okay, so there we go. There's our ogive, and we can go ahead and move on to the next question. Question 2.3 says, calculate the interquartile range of the above data. So the IQR, okay, when you're finding the interquartile range, do you notice that the word range is in this? Normally, to find the range, just the range of a data set, you take the highest, the maximum minus the minimum. So with the interquartile range, it's also a range, but it's a range of your quartiles. You know that you have a Q1, a Q2, and Q3. So the IQR, to find that, would be your highest quartile minus your lowest quartile. That is Q3 minus Q1. So that's what we have to find in order to be able to find the interquartile range. So how do we find Q1 and Q3? Well, with an ogive, that kind of information, it's much easier to find. And again, I'm just going to explain it because I want this to also just be a learning opportunity as well. So you can see your quartiles like it is a block split into 4 parts, right? If you're looking for the first quartile, right, like that number that's going to be there, that's going to mark the first quartile, what you're going to do is you can see that out of these 4 blocks, this is 1 out of the 4 parts. So in order to find that quartile, you're going to go ahead and say your total frequency. So it's like total frequency multiplied by that. So 1 out of the 4 parts, that would give you your Q1. Well, specifically the position of your Q1. Okay, so remember we're saying total frequency times that. The total frequency that we had was 50 because that was the highest. When you added everything up together, you saw how we added that. If you add everything, it will give you 50. So because of that, we're going to just say 50 multiplied by a quarter, okay, which is like 12.5, right? So 12.5. So now what do we do with this number? Remember I said that that's actually the position of the first quartile. We're taking this and we're multiplying it by that frequency, right? That'll just give you the position of it. To find out the exact value of Q1, you're going to take this number 12.5. Remember, this is a frequency value. So you're going to take 12.5 on the cumulative frequency column. And when we find that, so that's around about here, we're going to say this is 10, 11, 12.5 is here. And you're going to use your ruler and draw a line, a straight line to your ogive. And once it hits that spot there, you're going to go down. Okay, so we're going to go down like that. And you see that that number is about 10.5 because this is also in intervals of 1. So 10, 11, 12, 13, 14, 15. So that is 10.5. So when we answer them, we'll say Q1 is equal to 10.5 kilometers. Then we need to find Q3. So to find Q3, again, the third quartile, think about it as a fraction. It would be how much as a fraction of your data. So it's the third quartile. So this would be 3/4, okay, 3/4 of your data. So that, to find that, you're going to say Q3 is equal to your total frequency, and you're going to multiply this by 3/4. Okay, so that is the 50 times 3/4, and that's going to give us that's 25 plus 12.5, which is 37.5. So again, this is just the position of your Q3. That's just the position of it. So to find it, you're going to go on your ogive and you're going to look for 37.5. So 35 is here, 37 is 36, 37.5 is in the middle. Then I'm going to draw that line right to the ogive. And once I hit the ogive, so that's not a very straight line. It just needs to be, try to make it as accurate as possible just to help you. But don't worry, they have a range of answers that they will accept. And then if it goes beyond that, then they can't really, accept it. So somewhere around there, once you hit the ogive with your ruler, of course, you're going to go down. And then you see that it's here. It's about, we have 15, 16, 17.5. So I know that it's in between. So that's why I'm saying 17.5. So it means that Q3 is 17.5. So again, to find the IQR, remember how we find that? We say Q3 minus Q1. So that's going to be 17.5 minus our 10.5 kilometers, 10.5. And then, of course, the 0.5s cancel. 17 minus 10 is 7. So our IQR is 7 kilometers. Okay, so that's our answer. Please do let me know in the comments if there's mistakes that I made here and there. Okay, because remember the memo isn't really out. So I don't really have something to confirm whether, that was correct or not. Okay, so that's the answer that we get there. Then we move on to the next question. Okay, we're on 2.4 and 2.4 says, the families of 4 of the athletes above who stayed between 15 to 20 kilometers from a suitable training facility, okay, decide to move 10 kilometers closer to the facility. In which interval would the number of athletes increase? So the families of the 4 athletes who stay between 15 to 20 kilometers. So it's one of the people here. And I'm just going to actually pull this data down. I think it will just be easier to work with. Okay, so the families of people staying here between 15 to 20 kilometers. So that's this, right? So you see that there are 12 athletes here. So they're saying 4 of these athletes, what happened is that they moved 10 kilometers closer to the facility. Okay, and they want to just know in which interval would the number of athletes increase. So let's actually just put down a picture of what's going on here. What's going on here is that the people who used to be here, 4 of them, only 4, they are going to move 10 kilometers closer. So let's just see it like this. The people who were within 15 to 20, which is this, right? Let's just put a line for the travel distance. So they moved 10 kilometers closer to that training facility. I'm just going to put that, say train, okay? Training facility. This looks like a prison, but okay. So we have a training facility and we're moving 10 kilometers closer. So you can think about it like this. If you're closer, the distance between where they now live and the training facility is now going to be shorter, okay? So 15, they used to be 15 kilometers away. Now they're going to be, if they're 10 kilometers closer, it means they will be 5 kilometers away. Then I'm saying 2, if they used to be 20 kilometers away and they move 10 kilometers closer, they would now be 10. Okay, so you can see where they end up. They end up where x is greater than 5 but less than 10. So that means that they will move from here to this class, because that would be the class that is between 5 to 10 kilometers. So it moves to there. Okay, so what happens with the people then? It means that the people, the 4 athletes, right, who are moving from this place, they are coming out of this class. So we will have 4 athletes leave here minus 4, and 4 athletes would go here. Okay, so at least now we know the class. That's actually what they asked for. They asked in which interval will the number of athletes increase, and that would be this interval over here, which is x is greater than or equal to 5 but less than 10. Okay, so that is the answer for that question. Moving on to the last question in question 2. So 2.5 says calculate the estimated mean distance that the 50 athletes need to travel after the 4 families have moved 10 kilometers closer to the facility. Clearly show all working. So they're really just asking us to calculate the estimated mean, but this is after those 4 families have moved. Okay, so looking at that, you see that I've already put the calculations that is going to happen here. So we know now that this value, the number of athletes here would change. It's 12 minus 4, which is 8. And here, this value would change to 11. So that's really all we have to do. And if you had to calculate the mean distance, even without this change, it will still be the same because it's the mean, okay? We just took out from here and put here. So nothing new got added. Okay, so this is what we need to calculate the mean. So the first thing we're going to need to calculate the estimated mean. Okay, it is estimated because we're using group data and not specific numbers. Okay, so the first thing we're going to need is the midpoint. And so this is really where the estimation comes from. So the reason it's actually called an estimated mean is specifically because of this. We're not going to each of these 3 athletes, for example, and asking them, how far do you live from a training facility? And then go to another one and ask, okay, how far do you live from a training facility? Because if we did that, we would get different values, but all those values would range between 0 to 5 kilometers. So instead of finding each of them, which we can't actually right now, instead of doing that, what we do is get an estimate of 0 to 5 kilometers, and we do that by finding the midpoint. So we say 0 is 5 divided by 2, and that would be an estimate of it. Okay, so it's just the midpoint of it, or an average. So that would be 2.5, and then we'll do the same thing here. 5 plus 10 divided by 2, so that's 15 over 2, which is 7.5, and so on to get the remaining midpoints of everything. And these are the values that we get. Then in order to continue with this, to find the estimated mean, there's another thing we need to do. You see, yes, we found the midpoint of these values, but remember that in this category, right, there are 3 athletes here. So the total kilometers that we would have would not just be 2.5. It would be 3 of these athletes 2.5 kilometers. Okay, so we're just really giving all of them in this category 2.5 kilometers. We're estimating that that's how far they are from that training facility. So in order to get to this part, we're just going to say that midpoint multiplied by our frequency. Okay, so we're going to say 2.5 times 3, the number of athletes that we have, and 7.5 times the number that we have here, which is now 11, and so on. And these are the values that we get. Okay, so we get all of those. Then now to actually find the estimated mean, because that's actually what we're looking for. We're looking specifically for the estimated mean. To find this, what we're going to do is, the way the mean is normally found is you take all the values, okay, that you have, the data points that you have, and then you divide by the number of data points. So the data points that we actually have here would be these. You see, because instead of just taking 2.5 kilometers, we know there are 3 athletes in this category. So the total kilometers we have is 7.5. So to get those values that we're going to add, we're going to take these values, right, and add them up together. So we're going to add all of these up together. And when we add them up, we're going to divide by the number of athletes that we have. So that will be the number of people that participated. And the total athletes we will find by, of course, summing this up. But the things, we already have that in the cumulative frequency. So that would be this value that we have here. The last value, which is 50. So everything adds up to 50. So whatever we get here, we divide by 50. And when we add that up, we get 675. Okay, so we're really just going to say our 675 divided by 50 to find our mean. And our mean is 13.5 kilometers. So that is our answer for the estimated mean. And that is it for question 2, which is a total of 11 marks. We are on question 1, and question 1 says, at the beginning of a season, the coach of a junior boys rugby team recorded the weight in kilograms of 15 players in his team and the number of push-ups that each player was able to do in 1 minute. The data is represented in the table and scatter plot below. The least squares regression line for the data is drawn. Okay, so you can see that they actually give you everything. They give you the least squares regression line, and then they give you the X and Y values. Okay, the first question is, we need to determine the equation of the least squares regression line for the data. Okay, so to do this, remember that the least squares regression line equation looks like this. Y is equal to A plus BX. So all we have to find is the value of A and the value of B, and then our equation will be complete. Okay, and how do we find that? Well, we'll find that by putting these values in the calculator, and then we can actually just find that. So you can pull out your calculator, and on your calculator, on your Casio calculator, you're going to press mode and then go for stat, okay, because that's really what we're working with here. And then once you go for stat, you're going to have to choose the option that says A plus BX because you're working with 2 variables, okay? So that's what you're going to choose there. Okay, so after you go for that option, you're going to see an X and a Y column appear. So you have to input your X values and your Y values. Make sure that you end up at 15 values so you are sure that the data is correct. Okay, so now that we have put down all the values, let's go ahead and find A. So to find A, now that we've put the values down, you're going to press AC, Shift, and 1. And then you will go for option 5, which is for regression. And once you choose option 5, you will see all your values, A, B, and really your correlation coefficient. So regression, and let's just see what the value of A is. So the value of A is 39.46. Okay, so round off to 2 decimal places. And then you can press AC, Shift, and 1. Okay, you really just need to press Shift and 1. And then again, go for option 5 for regression, and then we're going to go for option 2 for B. So say B is equal to, and we get negative 0.59. Okay, so now that we know our A and B values, so that would just mean that because we found those, we're going to put that in the equation. So Y is equal to, our A value is 39.46, and our B value is negative. So you see that it's plus a B, but it's negative, so it becomes minus. So minus 0.59x. And that would be our answer over there. Okay, so we got A and B, and we got the equation. equation of the least squares regression line. Okay, moving on to the next question. The next question says, write down the correlation coefficient for your data. So write down the correlation coefficient. So to find the correlation coefficient on your calculator, what you're going to do is you can just press Shift and 1 to pull up your info again, and then it's a correlation coefficient, so it has to do with the regression. So go for option 5 for regression, and then it's going to be the option with an R. So R is equal to, and our correlation, okay, I have to delete the B first. There we go. So our correlation coefficient is R is equal to negative 0.797. Okay, so that's going to round up. And because it rounds up, it becomes a 1 here, which is going to round up to the 7. And so that's just going to become an 8. Okay, so negative 0.8. If you like, you can write it as negative 0.80 or 8. It's still fine. Okay, so that is a negative correlation, and it's negative because your line is really just being slanted downwards. It's decreasing, but it's still a 0.8, so it's a strong correlation. However, they didn't really ask us for that, so that's really all they asked for. Moving on to the next question. The next question, 1.3, says, the coach uses the least squares regression line to set the target for the minimum number of push-ups by each team member according to their weight. Predict the number of push-ups that a member of the team who weighs 29 kg should do to meet the target. Okay, so let's understand that. The coach uses the least squares regression line to set the target. Okay, so all that really means is the coach is saying, everybody, this is the target you need to meet. Okay, that least squares regression line is the target. So depending on their weight, they would have to reach a specific amount of push-ups. Okay, set a target for the minimum number of push-ups by each team member according to their weight. Okay, so if you have somebody that, for example, weighs 40 kgs, this person is supposed to do this amount of push-ups. So once you reach there, you're going to go to the side and you see that the person is supposed to do about 16 push-ups. Okay, depending on how we look at it, it actually is on that line. So this person should reach 16 push-ups based on their weight. Okay, now the question specifically was a learner who weighs 29 kgs. Okay, so you can use the graph, you can actually use the equation. This would be better because remember that the equation of the line of best fit, okay, is represented by this line. So you can actually just use this equation straight away and get that answer. Okay, so we're just going to say this is our equation and we need to find the amount of push-ups that somebody who weighs 29 kgs would be able to do or should be able to do. So we have 29 kg is an x value, so you're going to put it or substitute it in place of x. So y is equal to 39.46 minus 0.59, and then in place of x we just say 29 kgs. So y is equal to, and you can do calculations here, it will work out fine. So 39.46 minus 0.59 and then multiply by 29. And that gives us about 23.22. That's what we get. Oh, that's 56. I see. 59. Okay. So it's actually 22.35. Okay. So the amount of push-ups, I won't really say 0.35 is a push-up because it's not a full push-up. So I'm just going to say that this person is going to do 22 push-ups. Okay, 22 push-ups. Okay, and that is the answer to that question. Moving on to 1.4. Okay, 1.4 says, write down the mean number of push-ups for the given data. The mean number of push-ups. Okay, the good thing about this is we already recorded the data, so we can actually easily find this. So on your calculator, pull out your calculator and press Shift 1, okay, to bring up your data. And after you press that, this time we're not going to go to regression. We're going to go to VAR for variable. So we're going to go to variable And then we need to look for the mean number of push-ups. So think about what push-ups are represented. Were those your X values or your Y values? The push-ups represented your Y values. So we're specifically looking for the mean of the Y values. Okay, so that is going to be that. Just make sure that it is that symbol and it's not the one with a cap on top of it. Okay, it's this one with a line on top. So the mean of the Y values, that is going to give you, okay, I must always delete my data first and then actually do that. If not, it just multiplies. So that gives you 18.33. Okay, so there, 18.33. I will just leave it like that, but the mean number of push-ups is really just 18. Okay, so on average, the class or the team did 18 push-ups on average. Okay, so that is 1.4. Then moving on to 1.5. Question 1.5 says, the players trained hard during the season. At the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the season. How does this increase in the number of push-ups influence the standard deviation of the data? Okay, so let's see. They want us to tell them how the increase, right, in the number of push-ups is going to influence the standard deviation for the data. So when you're looking at it, it's kind of like this, right? You have the information, your data points that are spread out like that. Okay, when you get all the data points and you add them up together and you divide by the number of points that we have, you get your mean. Okay, so now we can focus on the mean. We don't really need, well, for standard deviation, we'll use that data. When you're looking at what happened here, okay, so it used to be like that, and then everything increased by 5 push-ups because everybody did 5 push-ups extra at the end of the season. So 5 push-ups extra, and so what happens is it pushes all these data points up, including the mean. The mean will also increase by 5 because all the 5s of the 15 learners get added and then divided by the amount of 5s that we have, which would be divided by 15 sets of 5s, which will still give you a 5. So how does this affect the standard deviation? Well, you have to understand what exactly standard deviation calculates. When you're looking at the standard deviation of data sets, what it does is this. It looks at each data point, right? And it looks at how far each data point is from the mean. Here's an example. We know that the mean is 18, right? About 18.33. Let's say it's 18. And let's say this data point over here was 21, for example. And then this one was 22, right? This one over here. What the standard deviation does is it's going to look at the distance or how far these data points are from the mean. Okay, so it's going to look at that difference there. How far is that data point from the mean? Well, this data point is 21 and then this is 18. So it's 3 units far away, okay? They're 3 units apart. So that little 3 we have there. And then this one, it's 22, right? 22 push-ups. Then how far is it from the mean? It would be 4 units away. And then it's going to calculate all of those. Maybe that one is 5 units away and so on. And it's going to take all those differences, add them up together and divide by the number of values that you have. So at the end of the day, the standard deviation is really just an average of the distance between the mean and each data point. Okay, so it's really an average of how spread out the data is. So that's why we say standard deviation is a measure of dispersion. Okay, so that's really a quick explanation of what it does. We wouldn't calculate it like that. There's actually a specific way to calculate that standard deviation, but that's really what it does. So now think about that. If these same values, right, as they were like this, if they increased by 5 push-ups, you had this and it increases by 5 push-ups. Now your new mean is at what? It's going to be 18 plus 5, which we have now 23. So it will be 23 and all these other points will also increase by 5. So this one used to be 21. It will now be 26. And that one used to be 22, it will now be 27. Now look at what happens here. If you look at the mean and how far the mean is from these data points, look at that, 23 and 26. How far is that? It's 3 units apart. And what about the 27? 27 push-ups and 23 push-ups. How far is that? It's still 4 units away. Exactly the same as it was here. This was 3 units away. That was 4 units away, and so on. Okay, so you see with those differences, you see the same way they didn't change is the same way the standard deviation is also not going to change, okay? Because the standard deviation measures how spread out the data is. The data did not become more spread out. Everything just increased by the same amount. So they're still at the same distance apart from the mean that they used to be. Okay, so how does that influence the standard deviation? It has no effect on the standard deviation. It does not influence the standard deviation. Okay, so that is our conclusion. Moving on to the next question, 1.6. Okay, the next question, really the last question for question 1 says, at the beginning of the season, the coach used the least squares regression line as the minimum target for a player to aim for. We already know that. They told us that initially. They already told us that this coach has decided to use that least squares regression line as the minimum target. So depending on what each learner weighs, okay, they should reach a specific amount of push-ups. Okay, so we already know that. But the question is really, determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. Okay, you have to read into that. Determine the maximum possible increase. What is the highest possible increase, okay, in the number of push-ups that a team member, okay, must obtain to reach the minimum target? You're going to have to look at that least squares regression line in relation to the data. So remember, this learner that we are looking for, really this increase that we're looking for the highest possible increase that we're going to have in a learner. So with that being said, there are people that we can't consider. Everybody who lies above this line, we cannot consider because they've already met the minimum amount of push-ups that they need to, have met that minimum, because the coach said everybody has to meet this as the minimum. So everybody above this has already passed that minimum. So we won't consider any of them. The people we're going to look at is everybody who lies below this line. Okay, so considering from all these learners that lie below the line, where would the highest increase be? The highest increase would be by the learner that has the lowest amount of push-ups, because that would be the person that makes the most the most progress. Yes, that would be the learner that makes the most progress. So that would be this one down here. Everybody here, their increase will not be as much as this person, because this person currently is on, how much push-ups is that? Well, you can see that these are in intervals of 1. So 5, 6, 7, 8, 9, 10. Okay, so right now this learner can do 6 push-ups. But because they weigh 40 kgs, the coach basically says they're supposed to be able to do this amount of push-ups. That line, okay, that regression line is what's going to give you that minimum amount of push-ups they should be able to do at this point. So this amount, once we hit the line, we're going to go to the side and just see how much that is. And as you can see, that is 16. They should be able to do 16 push-ups. So what is the highest increase that we're going to have here? It's from 6 all the way to 16. So the highest increase in push-ups will be that difference, which is 16 minus 6, and that is 10. That will be the highest push-ups that we're going to have here, or the maximum amount of push-ups that we're going to get for a learner. All these other learners, their increase is not going to be that much. Okay, this learner over here is currently on 16 push-ups. They would just have to increase until they reach there. They would just increase till 20. So that's just an increase of 4. Okay, likewise with everybody else, their increase is not as big as this learner. This learner's increase is the highest. So that would be the only calculation. There's really that 16 minus 6 okay, to get that difference, which is 10. So the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target would be 10 push-ups. Okay, and that is our answer to that question. And we move on to question 2. Okay, we have question 2, and question 2 says, the cumulative frequency graph, the ogive, shows the time taken in minutes for 60 employees to travel to work each morning. Okay, so it's showing us how long 60 employees take to travel to work. And the first question is, estimate the median travel time. Okay, when they ask you for the median and things like that, it is quite simple when it is an ogive. So how we can find that is, first of all, we're going to find the position of the median. So the median is also known as Q2, and we're just going to find the position of Q2. Where does Q2 lie? And how you're going to find this is, remember that it really represents data being divided into quarters. So the median is the middle. It's half the data set. It's marked at half the data set. So the data set that we're looking for or looking at is the people, right? So at 50% of the people, that's where you're going to get your median time. So with the amount of people that there are 60 employees. So we're going to have to say, to find the median position, we know it is half of that data set, half of the 60 people. And we can see that this is going to be at 30. So by 30 people, now we're going to go on our ogive, and this represents the people. So we go to 30 here, and we're going to run until we hit the line. And once we hit that ogive, we will go down and we'll be able to see that. I'm just trying to be exact with these. The way it looks like it hits here, and then it's really just this, okay? And we'll just see exactly where it is. So the median time would be, let's just see what this is counting in. It's not very clear, but as you can see, this line is a line here, there's a line here, then there's a line after that, okay? So it looks like it's counting in intervals of, because that's 1, 2, 3, 4, 5, and that's the middle. So in intervals of 2. So 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80. Okay, intervals of 2. So this, it's kind of in the middle of 64 and 66. So we'll say that's 65. Okay, so there, 65. That's what I'm going to say it is. So the median time, okay, that median travel time is 65 minutes. So 65 minutes. And that's how we find that. Okay, moving on to 2.2. 2.2 says, estimate the lower quartile. So, like with the story with the median, and where Q2 is, Q2, the median is half, okay? It's marked at half the data set. And the lower quartile would be Q1. That one is marked here. And when we look at this, because it's really just a box that's cut into 4 parts, this is 1/4 of this entire box, okay? 1 out of 4 parts. So that is at a quarter of your data set. So to find the lower quartile, or first of all, the position of the lower quartile, Q1, we're going to say 1/4 multiplied by the total number of people that we have, okay? Which is 60 people. 1/4 times 60, that will give you 15. Okay, it's half of 30. 15. So on our ogive, we are going to, I'm supposed to actually put this here, and then, that's Q2. But on our ogive, we're just going to go to 15 and then go to the side until we hit the ogive, and then we're going to go down. Okay, so with this one, it actually clearly looks like it hit here. So I'm just really going to take it from there. So this is 40, and remember it's counted in intervals of 2. So 40, 42, and 44. Okay, so that is Q1. It is 44. So we're going to say, therefore, the lower quartile, okay, that is marked at 44 minutes. And there we go. Okay, so that is the answer to that question. Moving on to 2.3. So 2.3 says, estimate the interquartile range. Okay, this is a nice way of them asking you to find all your quartiles, really. Because to find the interquartile range, or the IQR, we're going to say Q3 minus Q1, because it's the interquartile range. It's just the range of your quartiles. Okay, so highest quartile minus lowest quartile. And you see that to do this, we need Q3. Okay, so that's what we have to find. They just really wanted you to find all three at the end of the day. So let's find Q3. How do we find Q3? So we first have to find the position of Q3. And Q3, when we're looking at our information and how this box looks, Q3 is over here. It is marked at the third block. Okay, so it is 3 out of 4 of your entire data set. So we're going to say is equal to, and we calculate this by saying 3 over 4 multiplied by the total number of people, which is 60 people. Okay, 3 over 4, we could say times a half is 30, and then add 15 on top, and that will be 45. So 45. We're going to go to 45 on the cumulative frequency, and we're going to go until we hit the ogive. So once we hit the ogive, we're going to go down and then see exactly where this is. So it's clearly on this line, this particular line here. And where is that? This is 80, this is 82, this is 84. Okay, so that's 84. And we can just write that down then. So it means that the Q3, specifically Q3's value, is 84 minutes. But remember that they want you to find the IQR. So we still have to find that. So the IQR is going to be Q3 minus Q1, which is 84, minus Q1, which was 44 minutes. And it's 44, which gives us an interquartile range of 40 minutes. Okay, so there we go. The IQR is done. Moving on to the next question. The next question, 2.4, says, the minimum and maximum times taken for an employee to travel to work are 5 and 20 minutes. Okay, they're giving you the minimum and the maximum. You can already tell. And remember, you have all your quartiles, so they probably want you to draw a box and whisker diagram. So, respectively, then they say on the scaled line in the answer book, which I don't have, draw a box and whisker diagram to indicate the distribution of the data as represented in the ogive above. Okay, so we just have to draw a box and whisker diagram. We have minimum, maximum. We have Q1, which was 44. 44. We have Q2. That was 65. Okay, 65, and we have Q3, which was 84. Okay, so we have everything. So to draw this down, looking at the numbers that we have, because I don't have that answer book, we'll use a number line. So we draw a number line, and you're going to have to now think about how you're going to count on this number line. Are you going to count in 5s? Are you going to count in 2s? Looking at the numbers, I would want to count in 5s, but 5s would be too much numbers. So how about we just count in 10s? Okay, so I'll count in 10s. Okay, our number line is done. And now let's just put down the values. So the minimum is 5. And so that's going to be kind of like the whiskers part. So that is 5. That's between 0 and 10. And we're going to put a circle for that. But because we can't see 5 here, we can just write it here. Okay, 5 over there. And then we have the maximum being 120. So we actually do have 120, and we can just mark it as 120. So you don't have to write it because it's already written there. Now our quartiles. So Q1 is 44, which is about here. Okay, so let's just mark that with a line. And it's going to just go down like that. We have 44, but because it's not written here, we'll just write it there, 44. Q2 is 65. So that's in between 60 and 70. And that goes over there. And we're also going to write 65 since we don't have the number. And then we have Q3 being 84, and that is somewhere here. Okay, so 84, and we can also write 84 down. Then go ahead and connect your lines, okay, to create the box, and then connect your box to the whiskers. And I just realized that I threw those whiskers too low. They should just be higher, okay, so that they can connect properly. Okay, so it connects like that and like that. And there we go. That's our box and whisker diagram. Moving on to the next question. The next question, 2.5 says, the company manager decided that all employees who travel for an hour or more will be allowed to work from home for part of the day. Okay. What percentage of the employees will be allowed to work from home for part of the day? So, what is the requirements for them to be able to work from home for part of the day? It's the employees that specifically travel for an hour or more than an hour. Those employees are allowed to work from home for part of the day. So, let's actually look for those employees, an hour or more than an hour. When we are looking at the ogive, okay, we can't really find this kind of information in the box and whisker diagram, because you see that this is only giving us information about the minutes, the time spent. Okay, it's not really telling us amount of people. Okay, with this, we need to find the percentage of employees, which is related to the people. Okay, so percentage of employees. Let's go ahead and look in our ogive first. So we're going to look for everybody who works for an hour or more than an hour. Where would they be? We're going to find those people at here. So 60, first of all, is an hour. And then everybody that is within that region would be over an hour. So how do we find out how much people this would be? Okay, so how you can find that is go to 60, right? And find out how many people are marked by 60. So when we reach 60 minutes, right there like that, you can see that it's really just this line. So it's just a line above this number that we have, 25. Okay, so that's 26 people that we have there. 26 people. That's how much people we have marked at 60 minutes. So we're just trying to find out people who are at 60 minutes and over 60 minutes. So to find out over 60 minutes, what we're going to do is you're going to have to look at everybody that is here. Right now, this is just the minutes. So take the maximum, okay? There's a maximum of 120 minutes. How much people were there in total? There were 60 people in total. So you're going to say, since at, it's really this part really, okay? Since at 26 people, all of these people here, right? They took about an hour to get to work, okay? Below 60 minutes. To find the people who took over 60 minutes, you're looking for people within this region. So that would be everybody from 60, okay, to 26. So say 60 minus 26, and that's going to give you all the people who took more than an hour to get to work. Okay, so that's 60 minus 26. And let's see what that gives us. So 60 minus 26. 60 minus 20 is 40. 40 minus 6 is 34. So that's 34 people. Now we know the total number of people who took more than an hour to get to work. But the question specifically asks you, what percentage of employees will be able to work from home for parts of the day? So we know that it's 34 people, right? But as a percentage, what would this be? Since it's 34, represent this as a percentage by saying over 60, because it's a total of 60 people, and then multiply by 100. Okay, and let's just see what that gives us. Okay, and that's going to be 56.67% if you round it off to 2 decimal places. So that would be the percentage of employees that are going to be able to work from home. More than half the employees. Okay, that is it for 2.5. And then we move on to 2.6. Okay, 2.6 says, employees work 8 hours in a normal working day. The manager decided on the following rule for time to work from home, okay, for the time that they're going to spend working at home. An employee is allowed to work half an hour from home. So employees are allowed to work that 30 minutes that they spoke about, right? Half an hour from home, okay, for each time interval of 20 minutes or part thereof above an hour taken to travel to work. Okay, wait, let me read that again. An employee is allowed to work half an hour from home for each time interval of 20 minutes or part thereof. Okay, so each time interval of 20 minutes or part of 20 minutes. So even if it's for like maybe they take 10 more minutes, okay, to get to work, it's still included in this criteria of that 20 minutes. So 20 minutes or part thereof, above an hour taken to travel to work. Okay, so the thing is, as long as they take more than an hour, so from 0 minutes to 60 minutes, as long as they take more than an hour, they're already going to work from home, okay, for part of the day. But now we just have to ask, for how long will they really work from home? That's really what we're going to look at here, because they say above an hour taken to travel to work. So as long as they take over an hour, they're going to work from home. Okay, so let's look at the question specifically. They say on a certain day, an employee takes 110 minutes, okay, 110 minutes to travel to work. We need to calculate the number of minutes this employee will be allowed to work from home on this day. Okay, 110 minutes. This employee takes 110 minutes. Remember how if you take more than 60 minutes to get to work, you are going to already work from home for a specific amount of time, depending on, how much 20 minutes intervals that we have. Okay, this employee took 110 minutes to get to work. So that's already past 60. So the minute we go past 60, the minute this employee takes longer than 60 minutes, we're going to now start counting how much 20-minute intervals they are. So after 60 minutes, a 20-minute interval later is going to be 80 minutes. So because we could find 20 minutes and the employee is not at work yet, for this 20 minutes that they spent still traveling, they have to work from home for 30 minutes. Okay, so now you must work from home plus 30 minutes extra. And then we'll keep counting the 20 minutes that we find. And again, 20 minutes, you're still traveling, you're going to work from home for 30 minutes. Again. And then that's going to be at 80, and then plus 20 is 100. Then from 100 to 110 minutes, because they took 110 minutes, it's only 10 minutes. But this is probably where this part or part thereof comes in. They said for each time interval of 20 minutes. Okay, so that's why every 20 minutes we're letting them work from home for 30 minutes. But they say or part thereof. Okay, so each 20 minutes or any part of 20 minutes. So even if it's 10 minutes, it's within the interval of, it's within 20 minutes. So they're still going to have to work for 30 minutes extra here as well. So it's included. Okay, just to make sure that this makes sense, I did a quick Google search of or part thereof so that we can see what that means. So the phrase refers not just to the entire piece, but also any little section of it as well. Okay, so when we're looking at that 20 minutes or part thereof, it means every interval of 20 minutes or any part of 20 minutes. Okay, 10 minutes is a part of 20. It's not a full 20 minutes, but it's part of it. Okay, so they're also going to work for 30 minutes in that case as well. And so how long is this employee going to work from home? It's all of these 30 minutes that have been added because of the 20-minute intervals that we have, or the part thereof, which is 30, and you can see it's 3 sets of 30 minutes. So 30 times 3, which is 90 minutes. This employee is going to work from home for 90 minutes. Okay, so therefore the employee will spend 90 minutes working from home. Okay, and that is it for question 2. And that is it for statistics and this video. And I will see you guys in analytical geometry.